Hello. All right, so this talk is about managing complexity with Terraform. Tips and tricks in the trenches. I work in cloud. I build a service in Oracle's cloud. We use Terraform for everything, pretty much when it comes to infrastructure, application deployment as well. So, been doing it for a little while. I just figured I'd come out and try to share some things with folks who may be newer to it, or maybe you're getting started and things are getting complicated. So some of this is just about how to manage that complexity. First, inside every developer that does Terraform, there's really two wolves. There's a conflict. You guys all know a parable about two wolves inside of a person? The first one prefers code that is easy to read. The second one prefers code that is really easy to maintain. A lot of times in Terraform, you end up having a trade-off between is it easy to read or is it easy to maintain? The one that wins is the one that you feed. Luckily, with these two wolves inside each developer that does Terraform, they both agree that well-organized code is the most important factor of Terraform. So whichever way you choose to go, as long as it's well-organized, that's the most important factor. And we'll talk about why as I go further along into the talk. Who here has ever been to one of these? Yeah, not a surprise, right? Now I'll go back a little bit further in history, maybe date myself a little bit. Who's ever been to one of these? A couple of you. So like the grocery store and the library, even Blockbuster, what do all these things have in common? They're really well organized usually, right? You go in, it's a late night emergency, you forgot some condiments and you're having a party the next day, you need to get some ketchup. You know right where it's at in the store because it's usually well organized, right? Your Terraform code is kind of that same idea. It should be well organized, even if you choose to make it easier to maintain or you choose to make it easier to read. And we'll see some examples of what that means shortly. My name's Justin Beard. Like I said, I work at Oracle. I'll throw again the QR code up at the end of the presentation, so no worries if you can capture it now. I've been at Oracle for about 3.5 years, working in Oracle Cloud Infrastructure as a software engineer. We're going to talk about what is Terraform for the folks that may be newer in the audience, online or in the room. We're going to talk about managing complexity for most of this talk. It's not going to be every edge case. We're not going to cover all the syntax features of the Terraform scripting language known as HCL. At the end, we'll look at some resources like where you can go to get more information from here because quite frankly, the documentation is excellent and you should definitely check it out. So what is Terraform? It gets really, really boring talking about Terraform because it's a kind of a boring thing. It should be somewhat boring, right? But we call it infrastructure as code. What that really means is you write code and you turn that code into your infrastructure in the cloud somewhere or locally. It doesn't have to be the cloud, but it usually is. Terraform is also a tool that lets you build, change, and version control your infrastructure. So as you write your code, you're going to be able to keep track of the changes that you're making to your services or to your applications. So this first part, what is Terraform really doing? You're writing code, and then you're doing something, some magic in the middle, and then on the other side of that pops out a network, some cloud compartments, a compute instance, maybe a load balancer. Think about infrastructure in those terms. That's what it means in this context. So you write your code, you call Terraform apply, that does the magic in the middle. Usually that's done through something called a provider. We'll look at those in a moment. And then on the other end, it goes to your cloud service, whatever that is. There's a lot of different ones that support Terraform. Here you'll kind of see the pattern show up a lot. Now at the very end of that apply, what usually happens is, okay, I've got some code changes. I added some new resources to my infrastructure. I'm going to version control the code, so I know what changed, right? I'm doing a pull request. Someone says, yeah, that looks good to me. Gets saved into the version control. At the same time, Terraform is keeping track of the state of your infrastructure, and that's really important. So it's agnostic by design. Terraform doesn't really care what your target environment is. In fact, you can even use Terraform locally, right? You can use it as a tool to manage containers on your desktop. And if I have time during this talk, I'll do a quick demo and show you what that looks like. But then, how does it talk to all the different clouds? We talk to Oracle Cloud, or AWS, or Azure, or GCP. We're using something called a Terraform provider. And that provider is the plugin for Terraform that lets you talk to each cloud. Okay, make sense? All right. Some alternatives if you haven't used Terraform that you might look into if you're interested in staying away from Terraform for some reason. OpenTofu is an open source variant of Terraform that you could look at. Maybe you've heard of Pulumi or CloudFormation. Those are all infrastructure as code solutions that you could also use. I use Terraform, so I'm here talking about Terraform. All right, so let's kind of get into managing complexity and what that looks like in Terraform. This is going to be code snippets, examples, and we'll just kind of walk through them. And if I can, I'll also show you some live examples. So what are examples of complexity? When you get started working in Terraform, it's kind of like, okay, what do I do? How do I structure this infrastructure thing? How do I write my code? You start putting code into files. And at some point, you get to a situation where you have, oh, there's a lot of repetition in my code. There's a lot of things that look complex or they're hard to read. So the first level is kind of like, when I say level, I mean like the easiest things you could do to start out are dealing with adding local variables in your Terraform code to help refactor things. You can add variables as inputs to your Terraform, so that lets you kind of parameterize your infrastructure before you apply it. You can also split your configuration into modules, and we'll look at examples of that shortly. And then this is kind of, maybe it's opinionated, but Terraform offers you a tool that lets you format your code. And if you apply Terraform format before you do your PRs, and everyone does the same, then you'll start noticing that the consistency. You know what to look for, you know how it looks, you kind of notice the indentation's consistent. So maybe that's not a new concept, but you get it for free with the command line. Kind of the next level, and it increases in complexity a little bit, that you're increasing the risk or remember the wolf who likes to read the code versus the wolf who likes to maintain the code. So breaking your Terraform up into multiple modules helps you maintain the code, just makes it easier to maintain, but it also makes it a little bit harder to read, and you'll kind of see those side by side in just a moment. And last, when you have multiple deployment shapes or environments, let's say you have a development environment, you have a production environment, maybe in development you're trying something new and you don't want to deploy those resources into your production environment. So how do you make that happen, right? How do you make your environment conditional? This is really flexible, it's really powerful, but it's also really dangerous. What if you accidentally turn off your database resource for production and you apply your Terraform change and you delete your database, right? That's a bad thing. So it's really powerful. Just keep in mind that it's also somewhat requires great responsibility. All right, so this first thing we talked about is how do we make Terraform code a little bit easier to maintain, sacrificing a little bit of readability. So we can add something called locals or a local variable into a Terraform script. And what this allows you to do is it gives a semantic name to what otherwise would be a hard-coded value. Now that's good for maintainability, but it does impact readability, because when you're reading through Terraform code and you're like, what is 8080? Well, it's probably a port. But when you start seeing those numbers or things hard-coded in Terraform all over the place, it can become a nightmare to maintain as you get to the hundreds or thousands or tens of thousands of lines of code. So local variables help to give semantic meaning to a name. Maybe you have multiple services, one running on a port A and one running on port B. If they happen to be the same port when you start your project, but later you want to refactor and change the port for one but not the other, find replace doesn't work anymore. So in those situations, local variables can really help. It also simplifies or reusing expressions. So if you start getting into complex expressions in your Terraform code, sometimes adding a little explainer variable in there just to say, hey, this is what this means. This gives it some meaning. And then when you use it later, you'll kind of understand intuitively. On the downside of it, though, overuse, it really does make your code harder to read, right? If you have variables that you've sprinkled throughout your Terraform code, you've kind of got to go back and forth to find the variable, figure out what the variable means. You know, so it is a pro and a con there, but it's which wolf are you going to feed, right? So here's an example. Creating a load balancer resource. This is not specific to any cloud. This is the structure you'll see regardless of what provider you're using. When you're creating a resource, you'll have some kind of a resource type. You'll give it a name. In this case, I called it some listener, and I give it a port 8443. Okay, and then later on, I have a firewall that I've defined. Again, this is not specific to any cloud. This is just to kind of give you a visual image of what this topic is referring to. So in both cases, I have this port, 8443, 8443, no big deal. It's 3 values. If your code is relatively small and you have this going on, this is actually probably preferred because it's very easy to understand exactly what you're doing, and if something changes, it's very easy to see in the code why it changed. On the other hand, if you have this all over the place, you can introduce something called locals. Now locals will allow you to refactor some values out. In this case, I'm doing something very simple where I'm just taking the port, adding a variable name to it, and then I'm using that variable throughout the same blocks In this case, it's a no-op change. If I applied this, there would be no change in the infrastructure when I apply it. It should just be a refactor, make it easier to maintain. All right. Can you guys all see this okay? So this is Terraform, and we have a Terraform in a directory structure. There's no magic here. You just create a folder, you create your Terraform files in it, you initialize Terraform in a directory, and what happens is you configure providers. In this case, those providers we talked about, I only have one set up here, and it's really, I did it for local development. I'm saying, okay, I want to just manage Docker containers locally. I don't want to do anything in the cloud in this demo. I'm just doing it just to kind of give you an example. And then I've created a resource here, Docker container, called it backend, wasn't very creative, and I gave it a port. Now if I go over and run what's called Terraform plan, you'll see Terraform is reading in that configuration, and it's trying to figure out what's different. What did I change? In my code, I added a container, so when I do a plan, I can see, okay, I'm adding a container. And this is very important if you have critical infrastructure, is that someone's able to review the changes and see what would be different if I apply this infrastructure. All right, so if I go here and I say Terraform apply, you can auto-approve if you want, if you know the change is not going to break anything. In this case, you can also just say yes. And Terraform has now created a container locally on my machine. It's pretty cool. Are you guys, is that interesting? Does that, yeah? I think it's really fun to be able to play with Terraform locally and try these ideas out and not worry about breaking prod or breaking your shared development environment. Anyway, so I can prove that's doing a thing. You can see, okay, I now have a container running. And if you have great power, you also have great responsibility. You can also then delete production accidentally, right? You got to be careful with it. It's just, you can see how quickly you can get into a situation where you're like, I didn't mean to destroy that. All right, so that's local variables. You create resources. You can then define variables or parameters to those resources using locals if you want. The next topic is kind of related to locals and variables, so I kind of club them all together, which is string interpolation. There's a lot of times in Terraform where you're giving a resource a name. You're like, okay, it's going to be some XYZ dev, some XYZ prod, or you're giving it some other suffix for some reason or prefix. With string interpolation, you can essentially do, if you're familiar with Python f strings as an example, you can take an f string, you can put a parameter inside the string, prefix the string with f, and Python will interpret the value as part of the string. Terraform can do the same thing. This is really good when you have like external inputs driving your configuration. It's good when you have things like dynamic display names. It's also useful in the context of modules, which we'll talk about shortly. On the downside of it, variables can increase complexity again. We're kind of going away from the readability, going towards maintainability. So which one of those two things are you going to feed, right? Like, to me, sometimes they can both work out just fine. Sometimes you have to make choices. So here's an example. We've already seen locals, so nothing new here. I've created a local called the stage, set it to dev, and then I've created a resource, a compute instance in this case, and I'm calling it API instance local stage. Well, we can see all the code in this instance on one screen. It's fine. You can see it's dev. It's going to create a name called dev. But in reality, when you have tens of thousands of lines of this going on, sometimes that's where you kind of need to remember you're switching context. So it's a trade-off. Now here's an example that's a little more complicated than a local, right? I'm declaring a variable now, which is a kind of same thing. It's not local to the file, but essentially it's allowing me to define an input to my Terraform infrastructure as code as a whole. In this case, I've declared a variable called stage. I've given it a type, string, a description, and a default value. Same idea. Instead of hard-coding dev to one local, I've created a variable and given it a default value. Now, whenever I run my Terraform plan here, essentially it would do exactly the same thing. There would be no change. All right, so let's say, go look real quick at this. Now, if I go back into GitHub or into VS Code, you'll see some differences here. So I've created a variable, I've given it kind of a default name, and I'm actually doing something a little more tricky here, and I'm introducing a new concept probably before we just talked about it, but that is conditional expressions. But when you start adding variables into your code, it's usually not just to do a string concatenation. Usually you're doing something conditional inside your Terraform. In this case, I've created a variable for stage, and if I go back to Terraform, you saw me do Terraform plan a moment ago. I've aliased that to TP because Why not? You can see we were, again, just creating another container. No magic there, right? Pretty easy. Add a variable, do a thing. Now if I come back and I say, you can see here the port is 8000. If I say, sure, stage is prod, you can see I'm getting a different external port now, 9090, right? Because I've set it up to be conditional in my Terraform. Uh-oh. Anybody ever YubiKey their code in the middle of a demo? I have, apparently. All right, so conditional expressions. We just saw an example of it kind of live, but essentially it's often paired with a data. So in Terraform providers, usually there's two things you get. You get a resource type or you get a data block. Essentially what those allow you to do is query information from your infrastructure. You say, hey, given some data in my existing infrastructure, I need that information to do other things down the road. Maybe you're setting up dependencies and you say, okay, I don't want to deploy this compute until I have a network. So conditional expressions are really useful when you're altering parameters based on those inputs. And then, of course, the downside is when you start getting those expressions, they're ternary. So you start nesting them, they get really deep, and it gets really ugly really fast. Again, we go back to the variables and locals concept. When you start getting really complicated expressions that are just difficult to parse mentally, consider using locals and variables and then using conditionals. So here's an example before. It's kind of silly, I know, but it's where we're at. So I've created another set of locals. I've defined another local variable for service port. And hey, if the stage is dev, use 8080, because I'm not using SSL. I just want to use, open port. And if I'm using prod or really anything else in this case, assume it's SSL encrypted and use 8443 instead. But then again, I just pass in the local variable into my parameters of my resources in Terraform. All right, so putting it all together, you've seen how I did Terraform plan, Terraform apply, and that kind of creates the resources. In my example, I used dev as a port for default 8080, and I used something else, in this case prod as 8443. That's kind of simple. Does that seem okay to you guys so far? Everything good? All right. Modules. Now, this is where it starts getting, when you're refactoring all your Terraform code and you're like, man, this is just kind of getting to be a mess to maintain. I had a fire drill in production last night and I had to look through like all this code to figure out what broke. And this is where modules kind of come into the picture. So modules are great. They allow you to reuse groups of resources. So let's say you're defining 10 things and you copy paste, define 10 more things, you copy paste. Anytime you get to that stage of Terraform where you're like duplicating code, that's a good signal that it's time to start thinking about using modules. It also really does simplify maintenance for larger configurations. So, if you have a massive prod configuration and a mediocre or small dev configuration, you can start using modules to help reduce the amount of things you need to copy paste everywhere. On the downside, it is harder to read without navigating to the source, right? It's an abstraction, so it kind of hides what's going on. It's really opposite of what you want Terraform to do. Terraform should be easy to read, but unfortunately, sometimes you also need easy to maintain. And then with Terraform refactoring to modules, you have to be aware of address changes, right? So if you change the address of a resource in Terraform, Terraform is going to assume it doesn't exist. What happened to it? It's going to either try to recreate it, or it's going to try to delete the existing thing. So you kind of have to have a strategy for how you deal with that. So let's talk real quick about what module refactoring looks like, and then I'll try to show you a demo. So here's my before picture. This is my quote-unquote easy-to-read version, right? If I'm going to take this and get rid of some of the duplication, I need to isolate the things that are different between all the duplicate settings here. And in this case, I have a listener, a firewall, another listener, another firewall. One was created for dev, one was for prod. And the only real differences between those things, in this example at least, are the stage and the port that I'm using for those two resource groups. So how do I then take that? Well, first I would create the module, and then I would, instead of defining the resources directly in my main TF or wherever I'm putting my code, I define a reference to the module. I say, here's a module, here's a source to where you can find the module code, here's the two parameters that I just declared. One was for stage for input, the other was for a port. So the typical scenario here is you start building your Terraform, it starts to get complicated, and you think, I may need to refactor this. It's just getting hard to maintain. So you do that. You take the larger chunks out of your big infrastructure configuration, you create the modules out of those, And then you reference the modules instead. Maybe your production environment has slightly more, slightly fewer modules. Again, earlier we talked about adding a feature to your application that maybe only applies to development, testing some new tech that doesn't need to be in prod yet. Modules are a good way to make that happen. And then to be able to reuse it later when you're ready to go live into a different stage. All right, so let's see if I can show that. I'm running out of time, or is it just, I'm good. I'm going to create a container. Okay, I've got my container running. And I'm going to pretend I've just made a change to create some modules. Let's take a look at the code real quick. So, you've kind of seen this before. I've got a variable for stage on input. I've got another variable for the port. And here I've got this thing called moved. So if I get rid of that for a moment, and I go back to Terraform, and I pray that it worked. Yep, good. All right, so if I do a plan, it's going to say, hey, you're adding a container. But it's also going to say, hey, you're actually deleting a container, right? Like, yeah, you put this thing in a module, but the address in Terraform state lived at point A, and you moved it to point B. Now Terraform doesn't know. It just thinks, hey, you deleted that thing. So one way to handle that situation, at least if you're on Terraform 1.5 and newer, is to come back and say, you know what, Terraform, actually this thing does still exist. It just exists somewhere else. And that's done with a moved block. There's other ways to handle this scenario, but in 1.5 they added this little bit of archaeology that you can, okay, look for it in point A. Terraform will now know, okay, it's moved to point B. So if this works, let's just give it a shot. Now you're seeing Terraform doesn't want to recreate anything. It doesn't want to destroy anything. It's just storing a reference to that move, saying, okay, I know I moved. Does that make sense? Good. All right, that's modules. So I took the original Docker container definition out of my main TF, moved it to a module, referenced it. So that refactoring, keep in mind, if you do refactor for modules, it's great for organization and maintainability, hurts readability a little bit, increases the risk in terms of, hey, I might actually delete resources if I'm not careful when I do it. Just plan ahead. It's not the end of the world. It's not super difficult. Conditional resources, this is kind of the last real thing, which is, hey, I've got features I want to deploy into an environment, but not another. I have a development instance I want to put on dev, something else in prod. It's great when you need to enable or disable a single resource, but you can also now, I think Terraform 0.13 allows you to conditionalize modules. So you can have actually entire groups of resources that you turn on or turn off, depending on some external parameter. It can make your difficult configuration really hard to reason about, right? Because you won't know except at runtime what's going to happen. So that's where that reviewing the Terraform plan can really save a lot of headache. Is, am I going to drop things I didn't plan to drop? Am I adding things I didn't plan to add? And unfortunately, with conditional resources, there's a non-zero chance that you're going to delete things you didn't intend to delete, right? So just make sure, if you are making that kind of change, that you review those plans pretty thoroughly. All right, so here's an example. I have a resource and I have a module, and right now they're not conditional. I add a local, which you've all seen before. And now I'm just saying, hey, is it enabled or not? Whatever that thing is, right? You'd use something more realistic in your prod code. Here I'm just saying, is it enabled, yes or no? And I'm able to use this meta argument called count. And with count, in this example, I'm using it as a flag to disable the resource. If the flag is enabled, I get a resource because the count is 1. If it's disabled, I get a 0, so therefore I get no resource, right? So that's kind of how it plays out. All right, so some hypothetical requirements changed. Maybe you have a load balancer, extra compute instance in prod, or something else in dev, and you set that variable to false for dev. You deploy your infrastructure, you get onto the network and maybe some API instance. What about prod? So you set it to true for prod, you deploy, and now you get the extra resource in production. So that's the whole idea behind conditional resources. All right, so some resources, where to go from here. How do you get more info on these topics? Quite frankly, the developer documentation for Terraform is fantastic. Okay, start there. Tutorials are great, that's fine. They have a lot of info on all the syntax, and the tips and tricks you can get from them are actually really, really fantastic. If you prefer the open source variant, there's OpenTofu. Their documentation's okay. Still start with the Terraform docs because OpenTofu is a fork of Terraform, so they're very compatible. Providers, check out their providers there for your clouds. Every major cloud has one. Also, the code that we looked at and the demos here are available on GitHub. If you care to look at them, they're kind of basic, but at least they give you something to start with playing. And if nothing else, I hope they encourage you to play with Terraform locally and try out things that you can do to refactor your code. So just to recap, we looked at what is Terraform. We talked about infrastructure as code. We talked about managing complexity and gave you some extra resources from where to go from here. Prompts for the images, because why not? Thank you.
Being here, I'm Andrea Griffiths. Before we get started with like the official, has anyone contributed to open source this week? Oh, I had to do fast hands. And I have a present for you, my friend. Nick, I'm sorry. I didn't see your hand. I had to do fast hands. You also win coolest t-shirt. Check out this t-shirt.
Following you to the parking lot.
We're not showing up online.
Oh, okay, perfect. Oh, what's not showing online? The screen? Oh. What did you see? Did you see anything at all, or? Oh, interesting. Okay, cool. Let's see. We adapt. That's what we do. Let's see. Let me quickly. Do you think if I mirror this display that might work better? Instead of extending, I'll just mirror it. Or, do you have an option to select the display? Or we'll do this. Thank you, and thank you for your patience. Okay, here too. Okay, then. And I'm sorry because I know it's, for the folks who are here, you're like, yeah, I can see it, but you know, we do kind of want the folks online to be able to play as well. They didn't get to come, so I'm going to try and change my monitor, okay? And if not, then I'll unplug and start over. And then you tell me if that works or not. Or you tell me if you want me to start and there's a way to add the slides later. Okay, I'm easy like Sunday morning though. In the meanwhile, I do have a couple of other little giveaways that we can do later, so.
I contributed just now.
You did? Just now? I love that. It's a miracle. It happened so fast. It happened so fast. Okay, well, I mean, listen, we're not and it's not fun times. Who traveled here from the farthest place? If you think you came here from the farthest away place. Where do you come from? Where do you come from? Florida. I'm from Florida too, y'all. Like, I think New York City is the winner. What is Chile? Yeah.
Portland right here, though.
Portland? Sir.
No, not me.
Oh, sir. Thank you. Thank you. Okay. Who's local then? Who came from down the street? Oh, well, that's too many hands, y'all. I can't help you. I saw another one over here. That's all I got. What do you think? No? Not yet? Okay, sorry. I hate that I'm making people late. Oh, hello. I know you from the internet. Thank you. Thank you. Internet friends are real friends, okay? They are, okay. Let me see. Not yet? You tell me and I'll do whatever you want me to do. I'm sorry about that. Okay. Well, so, I mean, what if I start doing like intros? Because the first two slides are just kind of like a quick intro for myself. And then hopefully we can get it. Or you tell me. I just don't want to make people after me late.
I think you're good to start. It is lunch after, so we're not too worried. But we did it.
Oh, you did it? Ah, hero! You see, where is he? You get a prize. Y'all don't realize that's like one of my greatest joys in life that not all the time, but sometimes I get to pretend I'm Oprah and say, you get that, you get that, and you get that. Not all the time, obviously, but it's quite lovely when it does happen. Okay, so now we're gonna hope I can see the next button because we couldn't use Google Slides. If it doesn't turn next, then, well, anyways, thank you all so much for coming. I'm Andrea Griffiths. I spend my days at GitHub with the joy of supporting all of you, of course. And in the past 3 years, the joy that's been adopting these internal tools. And of course, we have to use Copilot, right? It's been something really interesting happening in that we're seeing that they're the same exact tool. You know, you all have the same version of Copilot I do. And it's been adopted across organizations for like completely different types of industries. And we're seeing folks that have the same exact tool and they're having completely different outcomes. And that changes not only with the tool that you use, so whether you're a cursor person or a Claude person, I'm team use what makes you happy. Don't tell my boss. I hope they're not watching. But you're yielding completely opposite results even if you're using the same exact tool. And we started to think, well, a lot of that has to do with the tool itself, but turns out it actually has a lot more to do with the governance and the way that these tools are being brought into your organizations. So I nurse-night myself into a very dark hole of a lot of reading, and that's what I'm bringing you today, basically. Some of the learnings, the things that I think work, I mean, allegedly have worked for me. If I can turn my slide, here we go. Oh, yeah, I did it, yay. Okay, but it didn't turn over there. Oh, man, it's cursed. So I changed the slide, and it did, but it didn't move over here. Do you think, I can see on preview the slide. So anyways, I keep telling you the story, right? Yeah. I'm not sure why it didn't, sorry about that. Friends, I'm here to tell you I was doing so well this year because last year I had a cursed year with technical issues and presentations, and then I don't know what happened now. If you can go back to just where the room can see the slides, and then maybe we can edit the online version, if that's okay with folks. And I'm sorry about that. I know that's not ideal for anybody. You tell me what to do. I'll do whatever you want me to do. I'll do whatever you want me to do. But anyways, let's do show of hands. How many of you all have been given the opportunity, and it's been presented like that, you now have the opportunity to use a coding assistant, whether it be Copilot, right? And another show of hands, and of course, you know, like remember the camera is pointing to me, was that you were volunteer for this, right? Like how many of you would have like honestly chosen to have that opportunity as part of your workflows? Like day to day, I have my job and now I gotta learn to use this thing, right? Perfect. And listen, nobody's gonna know at work. We all love our jobs, yay. But realistically speaking, right, most of us have been volunteered to do this. We have executive mandates, you need to incorporate AI. This is happening at my company. We need to show how we're using our own tools. And we're starting to be rated and incorporating part of our usage as part of our performance, which is sort of an interesting concept, but there you are. So we were given this opportunity to adopt these tools, right? Many of us were voluntold to do this, but there is this clear shift happening, right? We've gone from coding assistants as autocomplete to now we have agents that are doing complete orchestrations. They are deploying code, and sometimes they're writing, they're testing, they're doing everything. And there is a challenge that we haven't talked about much, and is that those digital assistants, those digital pairs are now very much part of your organizations. And absolutely no one really told me, for one, how to work with them. No one has really made that connection of like, okay, how are we supposed to redefine what our organizational software development lifecycle looks like, incorporating these agents in. And so we're not only just adopting these new tools, we're changing the way that we're developing. We're changing the way that we're developing for like the time to come. This is the future. As many of us begrudgingly are doing things, we're not going backwards. If anything, they're getting embedded deeper into our entire life cycle. So it behooves us, something that Aaron said in the keynote this morning that kind of hit me like a truck, and it's like, well, you're gonna fight or you're gonna make the system work to your advantage, right? And if you were at the keynote, you know what I'm talking about. And so hopefully presenting to you this framework and these ideas is a way of you taking an opportunity to make the system as it is work to your advantage, instead of like me saying, but why are we doing that? It's too much. We shouldn't be doing things. So we go back to, so what do you want me to do? Are we able to? You got more? Okay, well, listen, we're gonna do it without slides. I mean, I do want you guys to see though. Let me see if, how about we turn this little monitor so that my friends can see? Yeah, will that work? Let's do that. In the meantime, let's do that. And I'm sorry, friends, but that might be, yeah, that might be the only way to go. And then you have to let me know if you actually see the slide move when I click next there. Did it move? Did anything happen? No? Oh, that's fun. That's really fun. Okay, well. Okay, let's see. I'm plugging the screen again. What do you see now? Okay, brilliant. Let's try and do, let's see. Let's see. Should we turn it, should we Control Alt Delete? Is that what we do? Okay, now I'm gonna try and drag a different window over there. Did you see a window coming over there? Is it coming? Is it coming? You see my mouse on the monitor, okay. How about this? Let's turn this back towards me so that I can see what I'm doing, for one, because then that way I can just use the same little one before. Okay, brilliant. Thank you all so much for your patience. Sorry these things happen. And this is absolutely no reflection on the organizers. They put on a fantastic conference. This seems just, sometimes that's how it goes. And there's nothing we can do about it, really. Okay, so now you see my mouse, and I'm just gonna put it over here where it says next, so that we can, boom, there we are. All right, money. Okay, so we go back to the way that pair programming started, right? All of you, if you were lucky enough to work in person in the office, you remember pair programming at the beginning. You used to go sit next to your buddy, one keyboard, both of you collaborating, sharing ideas, and both of you giving each other feedback, and it was all good times, right? And now the pair that you have, it could be Claude, it could be Copilot, it could be you're working within cursors, however, whatever you're using. So now you're using, instead of you and your body, you have this agent working with you, right? And so now you need to learn to work with the tool beyond learning how to work with your body and learn the feedback cycle and learn how to avoid bottlenecks and all that. And then we're not talking about that at all. So the organizations that I noticed that have been the most successful are those that are treating this pair programming experience and the way that you interact with the agents as, okay, this is a capable engineer also. We're not gonna call him a junior, because I feel like that's kind of insulting to juniors. But, oh, well, now we look at the little one. But they're looking at it more as, instead of looking at it as a, okay, yeah, this is a magical thing that's I can throw any issue that I've been unable to debug, and they're gonna fix everything, treating it more as a peer and someone that you can actually do this pair programming experience with, right? The folks that are adopting that mindset as a peer collaborator rather than a pair collaborator, yeah, they are being more successful. That's just the reality. There is a quick number here from a company that, not a fan, but they did a good survey. This came out last year. They say 50% of companies are going to start using agentic workflows in their software development lifecycle is happening. It's supposed to go up to 75% next year. And then, oh, we're good. Yay! Success. No, you're great. And then, so we have this massive adoption curve, right? Like it's going from 50 to 75 to, I mean, some people on the internet said we're all being replaced tomorrow. But then the same data show that organizational leaders also feel like they have big problems. Like 60% of them are very concerned about adoption, and it has nothing to do with the quality of the agent, the quality of your assistant, but it has to do with the actual organization orchestration of bringing the agents. It has to do with integrating with legacy code systems, and it has to do with you, because if you're not happy, nobody's happy, right? So that's what we're going to talk about today. The bottleneck is not the AI anymore, it's us in a way. And when I say us, I don't mean all of you sitting here. I mean the leadership that's pushing this massive adoption without stopping to figure out governance first. So there's been some really interesting conversations going on online, and this is for the folks that are online that can take a quick poll. And if you want to take it here, we can do show of hands as well, because I just told you a lot of problems. And problems that are not for you to solve, that are more relevant to your leadership. If you're an engineering manager and you're sitting here, this is also not a dig at you, it's just the reality. I'd love to know, show of hands again, and we can go 5-1, nothing. And again, the camera is facing me, so it's a safe space. How many of you are 100% or more than, you feel sufficiently confident in that your leadership's approach to adoption of agentic workflows inside your life cycles is good, it's efficient, they know what they're doing, they're giving us guidance, and I see no hands. And I see, I see a lot of folks that love their jobs, and they're like, yeah, five. Great job. No, but in reality, we're not. We don't have a high value of confidence in what our leadership is bringing to the table there. Because again, going back, we're great at spinning up the tools, but not so much about setting that standards. So this is intended to give that leadership an idea, a framework that you can then use. I read a ton of research. I looked at our own case studies with our customers. I looked at our own case studies internally. Because believe it or not, even though the GitHub Copilot is our Chinese star, we also have a lot of internal resistance to adoption of these tools. We still do. But again, we're not going backwards. If anything, it's getting more and more embedded. So hopefully by the end of this talk, you feel like you can either have a little bit more confidence in the way that you're presenting this to your teams, if you are in that leadership path. And if you're not, this is an opportunity for you to be the star of your teams. And if you're looking for a job, this is an opportunity for you to differentiate yourself from another person because you're bringing, oh, you're using these tools. I have ideas on how we can actually make this a better experience, how we can be more effective in our adoption. So hopefully that level of confidence rises. These are the 3 patterns that I've noticed work. And this is, again, distilled from a ton of research. I list all the case studies on the repo, and I'm going to share it with you. I'm going to go over each one of them just so that we can sort of have a general understanding of what the ideas are. And then I'm going to share with you the educational framework that's got some surveys and it's got some actionable things that you can take back to your teams. And then hopefully start either, again, setting up a little bit more confidence into your team leadership because now they have the tools, or you become that leader that's bringing those tools to your teams. The first one is standards over speed. I have seen catastrophic failures. And 9 times out of 10, it happens because teams jump straight out. They want to measure productivity. And I know that this isn't happening because you and your engineering leaders are saying, well, how fast are they going now? No, this is usually coming from higher up. They want to know how many people they can put in other things. Let's put it that way. And so the mandate usually is, OK, start measuring productivity metrics. Do it now. But turns out to be successful, you actually need to set clear standards first and set those paths is the most important thing that you can do. The teams that are not just throwing the tools are the developers and are actually taking the time to set the standards and investing in that documentation and doing all those things. They're doing much better. Then another pattern is the fluency, the independency. I'll dig a little bit more into that. And then standards over speed. I think that was the first one, and I was just backwards, and that's fine. So let's start there, shall we? The teams that are investing up front in documentation are doing a much better job at adoption and are having much better results. Why? Because they're starting with a more pragmatic approach. Documenting is so important. How many of us have been bogged down by doing ADRs? And sometimes it gets pedantic, right? You're like, why do we know what we know, but guess what? The rest of the humans in our team don't know, and the AI sure as heck doesn't. So having those clear sets of documents to begin with is key. When we invest in documentation up front and make it so clear that both the humans and the AIs completely understand it, they can follow it, you start building trust gradually on the output of the AI, but also the way that your team is integrating that. And we'll notice that the way that the generated code starts catching maybe edge cases that your own humans couldn't catch before. And it's not because the AI is getting more intelligent, although the models are getting better. It's more because you've done such a good job documenting what's good that is both the humans and the AI have a clear understanding of what that is, what success looks like. So to set ourselves up for success, we should definitely invest in documentation and setting those standards first. I like to think about the way we document this very much like ADRs. It can be pedantic, it can be case annoying, but you do it once and you're setting up yourself for success. And then I am that person. I am the chiller of my company. When there's something new and they say somebody wants to dog food this, I'm like the first one. But guess what? I am not the best person for you to invest time on because I am your eager and like I want to try something new and I'm going to give you positive, negative feedback. But if you want to incorporate this into your company and you're starting to feel some resistance, start with your more senior people. Those are the people that you need to go to first. And typically what happens, and this has been, again, from all the case studies that I've distilled through, Once those more senior folks are on board and they start seeing the wins, then it'll be easier for others to follow. So it's great to have your hype people that are like, yeah, let's do it, but maybe focus a little bit more on the senior engineering leadership there. So clear standards equal more effective AI. Then measure an experience and not just output. This is so key. And it ties into that productivity versus, okay, how fast are we moving? Teams are shipping faster, right? Like 30% faster in some cases. And I have some clear case studies I can share with that. But then underneath that speed, there is this fragility and this scary technical debt that we think is not our problem, but it will eventually become our problem. So that rising fragility, the code that is not understood, is a problem. Noticing the patterns of leadership that have been successful, when they see this, when they see, yes, they're committing, our engineers are committing faster. But sugar, do they know what they're committing? And I know a lot of us, I'm guilty of that because there's a lot of frameworks I don't know. I'm not a great developer. So I lean a lot on it. And then I'm like, well, did you really understand what you just did? So it's worth taking a moment to investigate within your teams if they're actually learning or they're just pushing pixels faster. Are they trusting the AI suggestions more or less? And this goes back to setting that documentation and standards. Once you know you and your leadership have determined what good is, it'll be easier for you to know if you're actually doing the right thing and if you're okay to trust it or not. And then the growing confidence, right? I know I've become overconfident on things that I have no business being in. And it's scary to build that technical debt not only for your companies, but for yourself. One thing I've noticed a company did, they started doing this 1 day a week where there is no AI tooling. And listen, I know this, like once you're used to the remote control, you don't want to get up and go turn the TV. I don't think they even make TVs like that anymore. So I dated myself. But, you know, do that for yourself, for your own competency. Take 1 day a week that you say, you know what? I'm not going to ask ChatGPT any questions today. And see how that feels. That's going to help you not only stay sharp and keep your skills sharp, but also thinking a little bit more independently, right? So the teams that are tracking experience from that point of view, measuring both the flow states, and yes, the speed is great, but also measuring the experience and those quality metrics, those teams are building some lasting capacity, not just velocity. That's the second pattern. The third pattern, it's this one that I think is one of the most important ones, how fluency beats dependency. And I'm, again, guilty of that. And this advice is coming straight from our own enterprise playbook. We designed these communities of practice internally, yet another Slack channel. But it's actually a really helpful Slack channel. It's called How Do I with AI. And people are coming in and they're sharing their wins. Be it tiny, be it big, just when they have those aha moments, you create an intentional space for folks to share it, right? And you can do it any way you want to. It can be formal, informal, it can be in GitHub discussions, as long as you're documenting these things. This is going to help the more senior people and your leadership that you're hopefully trying to win and get them to adopt faster, to become the mentors and facilitators. And then the junior people are going to learn to sharpen the skills to evaluate when I should trust this, when I shouldn't trust it. And it's okay for all of us to question it, right? All of that ultimately raises our AI competency for our whole team. So when we have these teams with the structured knowledge sharing, when we have this broad space where we can collectively, not only the wins, but also the bad points, documenting them, when we can discover and broadcast this and debate it openly, we're going to be more adaptable, more skilled, and more resilient than the teams that are just solely relying on a specific group of people that have been your believers from the beginning. But this is really empowering folks to share their experiences, their true experiences. So I shared with you these 3 patterns. This is all the pedantic, boring stuff from the talk, right? Like there was a lot there. There was a lot of information that came from the surveys. And then I started to think, well, what can we do? How can we apply that into a framework? And this is what I'm bringing you today. So again, it could apply to you, it could not apply to you. Maybe your team is already have a system in place, but I want you to take what's good and leave the rest. And these are 4 parts to this framework. Again, I'll share the repo with everyone so that you can sort of lean into it. We're going to take a look at the interactive tools. Again, proven on patterns that work, and then hopefully when I click here, it took us there, great. I was scared, y'all. All right, so I was a little bit terrified. So we're starting with this AI decision tree. So because we have these mandates from our leadership that we have to use AI tools, sometimes we're using AI tools for problems that we don't necessarily need AI tools for, right? So there's a little matrix at the bottom here that give you sort of an overview of some points that you can consider. And again, this is going to be more up to your organizational practices than any 25,000 pages of research that we distill. What your organization mandates will be key here, but this is a good starting point for you. And then so we can play around with it. It's going to evaluate whether it be from security risk level, from the experience that you have within your own teams. And then it might give you like a very high level suggestion, right? Like, okay, maybe you should start with assistance instead of diving in. I like this for myself because again, what is it, when you have a hammer, everything looks like a nail, what's the saying? Exactly. And sometimes you don't need a hammer. So it's a good way for you to take a moment of pause and evaluate what you're using AI for. And then go from there. Go from there. That is one of the points. Let me go back. The second piece on this is going to be this maturity assessment. And this is something that you can take back to your teams. And it's a 5-minute assessment. All it's going to do is it's going to give you some ideas of where you are in competency levels, on understanding. There's a lot of questions there that are a bit pedantic, but they have to do with documentation, and they have to do the weights on governance and policy. So again, these are all standard points, just standing points. If you have set standards for your organization, please take those and dump it into something that LMs love to read, and then go back and alter this so that you're actually working with the guidance that matters to you. It's going to give you a score at the end, and then you can go from there and kind of assess what areas you and your teams should focus. And if you're working on your own, you're like, Andrea, I'm a team of me. Well, you should still start setting those standards for yourself, because hopefully one day your team grows to 2 and 3 and 4, and now all these things are documented and you're ready to scale. Then the third piece to this framework is going to be the teaching moments. These are just simply templates that I said. There is a couple of a quick capture one and a detailed learning entry. And you can see that the questions are kind of, okay, well, what does that mean? This is just to make it easier for you to start thinking about what should I be documenting. We have very set practices internally for what an ADR looks like. We have 0 set practices internally for what feedback on the tools that we use should look like. And so when we start setting those standards, again, knowledge and data are power, so we're able to actually set that. And then finally, my favorite, and I think the most important thing that we need to focus on, and that is the developer health check. And again, if it's a team of you, a team of 20, it doesn't matter. Start looking at the way that you're integrating tools within your own workflows, and then start really pragmatically evaluating, did I need a hammer? Did I not? Am I using the best practices? Am I not? There is a ton of stuff here that you can scroll through, and the focus on time, I'm going to scroll rather fast. And then on like a true meta way of living and life, I added some open field questions. And because I'm not a backend developer, this has no backend. I'm not collecting your data. It's running off of GitHub options using the inference from GitHub models. If you want to fork it and add a backend and use it, go for it. That would be amazing. But it's based on a prompt that is distilled again from the research, but it's going to evaluate the weight of the answers in the scores plus these open questions. So this is where your brand new rock star can say, I really hate this tool. Why are you making me use it? And one thing that I would suggest is that you give this as an opportunity for people to be completely open and honest, and just provide this feedback on an anonymous way. If you're a team of 1, well, you know what's up. But if not, then it's an opportunity for you to actually have actionable data that you can then benchmark, you can then go back to. And as you're shifting focus and you're thinking, okay, what can I do to encourage developers to actually use this tool? Then you have something to measure it against. I'm going to ask you this question now, and then 90 days from now, I'll go back to it. So just some small things that you can start doing today. I'll go back to the presentation quickly, and I know we're close to time and I don't want to cut off from your lunchtime. But once we get through this entire sort of framework of tools, again, take what you can, use what you want to, leave the rest. I just don't want us to forget that all of this is just for us to be amplified at work. I hate people that are saying that we shouldn't learn to code anymore because now we're being replaced. And honestly, I think it was Andrew Yang did this talk a couple of weeks ago. I'll link it on my notes as well. He was like, every time that software development has become easier. There's actually been more people that needs to learn to code than otherwise. You know, like from punch cards, like assembly, COBOL, and now AI assistant. This is not changing. So it's important for us to maintain our place in this space and to use the tools to our advantage. So like Aaron said today, you know, do we need to set it on fire or do we need to make it work for us? So remember, those patterns are going to help you sort of separate the chaos from the winning. And if you don't work in a team or you don't have a need for adopt this, it doesn't matter. Adopt it in your own practices. I think it's going to help regardless. So take some agency on your own usage. I've done this. It's a hard look at myself, y'all. It was not easy. But what is helping, what is not, what I'm overusing and what I'm not, what I should sharpen skills, what I can focus. Taking the survey, as pedantic as it might be a moment of pause for you to really evaluate how much are we leaning on. And then once you have that information as a team, then you can set the appropriate guardrails. Then you can set the whatever data access rules, whatever other maybe security key points you were missing that you haven't communicated to your team. And guess what? If your team doesn't know it, the AI for sure does not. This is why documentation is so important when it comes to this. So of course, just some very abstract idea what to expect. I wanted to do a slide with somebody crying, but I thought I'd keep it professional here. But when you first bring these tools, 9 times out of 10, people are going to be sick and tired. I have so much work to do. I don't want to go learn how to use something new. But again, this is the vision that we are now in and that we're sold on and where we are. So week by week, hopefully, ideally, you'll start seeing some more buy-in. You'll start seeing people sharing those aha moments. If you create those spaces intentionally, that's going to be good for you in the end. And then hopefully your teams become the teams that everyone wants to be a part of because you're the fun teams. You're the cool teams. You're the teams that people want to learn in. There's a really good study by Microsoft that's based on like an 11-week ramp and rate of adoption. I'll share that as well. So ideally, I wanted to put this here because I want us to remember that this is not an overnight process. And we can go at it like bulls and ram down. And I know this has been the experience for a lot of us, where we have been forced to do things. And now, by the end of this quarter, I need to see how much you're using this tool. And your rating depends on it. And so let's take a moment of pause and kind of stop bulldozing and stop hammering things, especially if you're a team leader. And keep these principles in mind. Establishing those guardrails and measuring the impact in this way is going to help us so much more in the long run. We're seriously redefining the way that software development is going to work in the next decade. And it's up to us, y'all. It's up to us. We have to do this work. I like this, keeping humans in the loop. For security purposes, of course, human in the loop is so important, but also for taste. Because I think we're in a moment where we're changing the way that code is. And if we don't voice our opinions and document it, it's going to look the same. Like it's only going to look, I dare say, worse or not ideal. So again, some 30 to 90 key points for you to think of your ramp up, think about what you can start doing today, do your own code review checklist, and then find some safe use cases where you can maybe 1 point in your software lifecycle you can start assigning to AI, maybe 1 point. And if you feel like confident enough that you can use that as a guinea pig to establish these processes, then you scale that out. Focusing on developer sentiment. I know a lot of us have been of that school of like, what is your job and your sentiment should be you get a paycheck, but I promise you, you'll have a much happier workforce and a much easier adoption of these tools if you take a moment to actually measure that experience and then take that actionable feedback into whatever it is that you're bringing to implement. When you do that, then you can focus on the rest because honestly, only 20% of the day is code. The rest of the time you're planning, the higher you get in your companies, you're more concerned about politics and orchestrating and what vendors you're using and testing new use cases. So just keep in mind that only 20% of it is code. We can make that easier and we can make our implementation of this better. So all that to set the guardrails that are important. So pick one workflow this week. It doesn't have to be something huge. And then add one metric. One metric that I want to share, and I don't think I put it there, is like maybe instead of measuring the lines of acceptance, and this is something that Copilot as a whole is getting some really good investment on metrics for you, all of you to see. Instead of, okay, I accepted this much of it, how much did you reject? That's a good point of sort of you saying that understanding of your own usage. And then if you're, at the team level, organization level, there's going to be other dashboards there where you have more intelligence. I hope that you can take one of these things with you today and that you can use them. Again, all of this is going to be in a repo. It's open, fork it, destroy it. There is no backend to it. There is no data retention. But I do want you to hopefully go back to your teams with a better idea of how we can keep the taste in, but also work better. And I think that might be my last slide. That's it. Thank you all so much for your time. You're awesome. Thank you. Thank you. Thank you, thank you. And this is the short link. It's peer-to-peer. I'd love for you to go in, and if you actually end up using it, send me a message, let me know. If you're like super nurse night into things, like I normally am, and you actually end up submitting a pull request today, let me know if you do it before I leave. I'll dig into my bag and see what else I got in there. But honestly, I've seen so much success, but also so much epic failure. And I really think it's us. We're not doing a good job at talking about it. That's another point from Aaron's amazing presentation. It's like, you gotta talk about it. So I'm happy that I was able to do that, and I hope this wasn't too fast and too furious for all of you. I am a la Colombia Dev online. Happy to talk to you all outside, at lunch. But thank you. I appreciate you being here. I know you had a lot of choice. I wanted to go to Rizel's talk, but I had to come. So I appreciate y'all. Thank you so much. Okay.
Okay, well, thank you everybody for coming to my session on handwriting recognition for the New York Times crosswords. So a little bit of context about me before we get started on what this all is. I'm a games engineer at the New York Times. I work on platforms such as our crosswords, and I work on the team that produces Wordle, Connections, Strands, Pips, a bunch of games that we've come up with and that people play from all around the world. So prior to this, I worked at the NBA, working on live streaming platforms, Business Insider, and MTV. So my background is mostly in the media space, as it is at the Times right now. Inclusively, prior to my actual application development background, or in addition, I have an AI and ML background, which I've had for quite a while in traditional ML and AI. So some of that leads into the talk that you're about to hear. And there's some of my socials here, in case you want to connect. So a little backstory to the project. This effort started as a part of what we call Maker Week, which is our internal hackathon that lasts for a week, where people can come up with interesting projects, interesting ideas, and like potentially road-mappable projects. This was from a few years back, where people are interested in using a stencil to write on the New York Times crossword app. If you're an iOS user of our apps on the crossword, there was some level of handwriting recognition available, but Android support was not present, and primarily being an Android developer on the platform and working on the application, it would be a little trickier to get that implemented. But it was started as a fun project, and then it turned into a good learning exercise, and then it actually produced a bit of interesting research in the area of handwriting recognition. So before I continue, our games team, specifically the folks on the Android side, are the true heroes of the New York Times Android mobile app. I am currently on a different project right now, but these are my friends and colleagues, Katie, Lauren, Joanne, Vanessa, Vasil, and Ihor, and they work on, if you're a fan of our games, you can enjoy our games because of their huge efforts on Android. And iOS also has a team. So let's talk about straight away what the problem is. And it sounds straightforward, but actually it gets a little bit into the weeds. So the crosswords as existed before allowed the ability to only do text input via custom keyboard. So this soft keyboard is one that we built, and you could input characters from this keyboard. And I don't know if the actual visual is going to play here, but basically what it looks like is, if it does play, is that the characters get emitted onto the keyboard, and you get to see the output. Part of this, let's see. So in order to have the ability to write in these squares, we added a tiny canvas to each of the letters and the input boxes that you see here, and implemented a touch point tracking algorithm. I'll go into the details about that in a bit. But after writing is done, the canvas's data is converted to a bitmap and sent to a machine learning algorithm. So what you'll see is that, and again, if the visual does actually appear, which again on PowerPoint there's a little issue sometimes, you need to let the system know that the user was done writing. This is tricky because essentially people have different writing capabilities and writing styles and writing timings. And so in order to partially solve this, we used what's called a mutex. We called it a mutual exclusion lock. That's similar to the way that you would do in the world of threading. But this is also tricky because people have a different type of reset timing for when they enter a letter. So if they lift up their stylus, as you can see on the box on the right, if you do it too fast, then it's not going to necessarily capture all of the pen strokes and form the correct word or correct letter. And all of this work that we're doing, it needs to be user tested more, but for the context of this application, the timing seems to work out, but I'll get more into the details there later. So a little bit of code on the right. I'm not going to get too deep into all the details, but this is essentially a soft lock and release mechanism, which takes in, if you're familiar with Android development and coroutines, it's essentially a way of taking a thread that checks in the background for whether an input has been made, and then waits a few seconds, 2 in this case, and then allows more input into that box that you saw. So basically, we have a touch event. Like if you are touching at any point on that box, that kind of triggers whether you can write on that square. And so that touch event essentially is where this lock gets actuated and allows you to be like, oh, okay, here's a place where I can put another pen stroke within the time. So you have to be a little fast about it. And then you have a release mechanism which allows that to then lift again for if you're truly done writing the character. So this is the architectural components of this system. So you have a finger down, finger drag, finger up stylus listener. And you have a canvas square, as I talked about. So this is on the mini crosswords. We have the mini crosswords, we have the full crosswords. The reason I chose the mini is because the mini crosswords, if you're a fan of our games, has a big enough square to be a good test bed for this. But the actual crosswords requires more work. And then, because this is an AI talk, an AI custom model we built, we needed a algorithm and process to download the model and then actually take the image data and send it to the model and produce a text output. So that's basically that seems pretty straightforward and like a solved problem, but because OCR has been around for a long time. But in our particular case, is actually more challenging, and I'll go into why. But first, before we go into the details of that, I'm going to talk about so-called relaxing conditions. And what that means is that relaxing conditions and pre-processing. So we have certain cases, we're not looking for like very complex handwriting right now, what they call connective cursive. We're looking at straightforward letters with some variation in the letter space. And what we have to do in order to produce those letters is that we have to create a pre-processing algorithm. And so this pre-processing algorithm is, as you can see, steps on the right. You take an input image, you denoise it, and you binarize it, which means you take the grayscale out and just create a threshold for the black pixels versus the white pixels. And then you anti-alias the image so you can make sure you get the smoothness out of the character so the machine learning algorithm can understand what the character looks like. So actual OCR is actually can be quite involved, and I'll go into more into why that occurs. So the first, I'm going to speed through these parts a little bit because I'm going to get to the meat of this because this is actually part of a larger presentation. But we started initially investigating with classical edge detection, rudimentary k-nearest neighbor classifiers, and we went from that. We went to Google ML Kit, something that comes on the device already, and then we tried to do a custom machine learning model, which is what I'm going to be talking about now. And that used a convolutional neural network. So I don't know how many people are familiar with that term. If you're not, then that is a particular neural network that's geared towards image recognition and digit recognition. So start off with classical edge detection. I built a classical edge detection filter system on the right to demonstrate what that looks like for those not familiar. But classical edge detection is specifically around thresholds and looking at boundaries of images to find what could be good features or feature spaces for an algorithm to track, to be like, okay, this is a letter or this is a different kind of image. So basically classification. And as you can see, this is kind of, if I put up an image of my own headshot there, this is kind of what that does. And similarly, if it kind of went past it's a GIF, but similarly, I would do the same to the actual letters, and it would show the edges of those letters. Now, essentially, this falls under a process called canny edge detection, and canny edge detection is good. It is not really the best for the modern day, especially with a lot of variation in your input letters or words. So essentially what happens is that you find letters, and then you create what's called a clustering space, and you create clusters. And so this algorithm on the right, which I put together, does the threshold detection. And it's okay, but ultimately, it's not sufficient, and I'll show you why visually. So basically, this is what it looks like between a good edge detection clustering algorithm and a bad edge detection clustering algorithm. What happens is if the letters don't have a ton of variation between them, the letters are great, and they can be separated into their individual clusters. But if the letters have a lot of like interspersed variation, then clustering fails because, as you can see on the right, the clusters actually start to merge together, and an algorithm to detect differences between letters becomes confused. And so that would be why classical edge detection doesn't work so well. And this is, again, I don't know if this GIF is going to fully play, but what you would see here is that the letters actually don't render well on this image. You'll see like mistakes and other things in the actual output. So what we moved to next was we were using Google ML Kit. And Google ML Kit is great. It's really powerful now. 2 years ago when we first implemented it, it was not sufficient to actually solve this problem. So the good thing about it is if you don't care about the model mechanics or the mathematics, you can use ML Kit to do good digit recognition right off the bat. But again, at the time we were doing this, it was not sufficient at all for what we were doing with the crosswords. And just a little bit of the client-side integration for that, it's actually pretty straightforward. That's why a lot of people like it. And all you need to do is add a listener, download a model, and there you go. You don't have to do all the stuff that I'm going to get into. And again, the performance, if the GIF doesn't play, is so-so. You'll see the letters being entered, but they're not that great. And so ultimately, you'll see like mixed results with recognition. So finally, we went to a TensorFlow Lite model, which is Google's framework for Android and iOS devices to take a machine learning model and put it on the device. And the way we did that is we worked with Google Colab and Jupyter Notebooks. I don't know how many people are familiar with those, a few people might be. You can build a machine learning model in those frameworks and then pull them via TF Lite onto your device. Also, if you're interested, there's tons of free models out there for other things besides handwriting recognition. So it's a really good platform, but this is the architecture on the right. So the first thing we had to do is actually train the model. And the simplest text recognition task is digit recognition 1 through 9. And so digit recognition, has anyone ever done an ML course, is a canonical machine learning task. Everyone kind of goes through it. In our case, it's a little bit more complicated, and I'll again go into why, but the digit recognition problem was most effectively first solved in the late 90s by Linnet and the convolutional network model at that point. Again, it's easier than full letters because it's digits. You don't need the full set of letter data. And in order to do this task, we used a digit data set called MNIST, which has about 60,000 characters. So this is basically the structure of the convolutional neural network, for anyone not familiar. The convolutional neural network is, in my opinion, a magical piece of technology. You send an image to this network. This image then is broken down by the network's components, which are called convolutional layers. The convolutional layers automatically detect what's in the image. So you actually don't have to provide a ton of intelligence, except maybe some pre-training to the image. And then the classification between different kinds of images is automatically learned. And why this is magical is because, again, back in the day when people were doing image processing, they were creating very custom filters to do image processing, writing these very complex algorithms by hand. When the convolutional net came by, and then in 2012, when the AlexNet ImageNet challenge was essentially solved, that computer vision was basically a solved problem. And so with a pretty straightforward model, you can do almost all computer vision tasks. And so there's a lot that goes into this. We talked about pre-processing. As I showed you, those images are grayscale down. We send that over to the convolutional network, which mixes and matches input and output data and sends it through a standard neural network, which is this dense layer section here. And these cascading layers, essentially adding more layers produces better results. So we needed a complex layered network to create this handwriting recognition possibility. And these are the types of layers in there for anyone interested: convolutional layers, pooling layers, and rectified linear unit dense layers. And so those structured together allow for handwriting recognition to occur, or any recognition on images to occur. This is an example on face detection. So the idea is low-level features, mid-level features, and high-level features. This network that I showed you here breaks down those features into, does the same thing for faces and breaks faces down to things like curves of faces, then maybe eyes, nose, ears, and then high-level features, which include all different kinds of structures of the entire face. So on the client-side level, we take the model we built on TensorFlow, we pull it down into the client code on the device. That's this client code. and then we can run the model. The model is actually pretty small, about 100K. And this simple convolutional neural net, this is the Python code. So I just want to clarify that there's two kinds of code involved. There's Python code, and then there's Android native Kotlin code. The Python code is where we build the model, and this is the neural network model for anyone who's interested. And in the Kotlin code, which I showed you before, is where the code actually runs on the device. The GIF is not going to play, unfortunately, but basically, this is showing the training of it, and that training is about 98%. It says we're doing really well, but that's actually a suspect number because we essentially weren't able to get good recognition. In the GIF, it would show that you actually are able to get like almost no classification off that. Like an A, entering an A would produce a 9, entering like a C would produce an 8 or something like that. It would be completely messed up. And the problem is that in order to allow that to work properly, you can't, 60,000 characters, as I said, is in the previous data set, is not sufficient to give intelligence to this model. What you need to do is actually produce, again, I don't know if the GIF's going to run. No, probably not. What you need to do is build a synthetic data set. So anyone familiar with synthetic data here? Synthetic data means taking my digits and applying algorithmic affine transformations to stretch the data, to twist the data, and to add noise to the data to make artificially inflated additional numbers to make my classifier much smarter. And basically, you can warp these numbers, rotate these numbers, add noise and other things to make the model much smarter. Because essentially, some of these, you just can't collect all these variations. So you actually need to increase the number of data. So basically, all these techniques, which I showed you on the right here, it takes our data set, transforms the MNIST data set from the very centered, nice data set on the left to this highly skewed, highly rotated and stretched data on the right, which gives us, starting with 60,000 characters of training data, up to 1.2 million characters of training data. And that makes our model much smarter. And so again, if the GIF played, you would see that the number detection is actually a lot better. And you'd see the results showing that numbers are great. And so this is basically the code to do this sort of processing, this data augmentation or image augmentation. And this, as you can see, I can define ranges of angles and other things to stretch and change everything to make sure that I can add enough variation to make my model very intelligent. But now with letters, that's one thing. With numbers, that's one thing. But letters, there's many more letters than there are numbers. And so this is called the extended MNIST data set collected by Google, which allows you to add letters in terms of digits on top of digits. And letter recognition is a much, much harder task than digit recognition. You actually have to build a more complicated model and do a lot more things. And the convolutional model is still very useful and very important for this. GPT, all these big tools out there that you use, foundational models, use ultimately convolutional and vision transformer models under the hood to do this. But the complexity of these models increases significantly with the intelligence you need to provide the model. So again, this is me attempting to, like, again, the GIF's not going to play, but you would see that as you're entering the digits, as you're entering letters into the digit brain of the model embedded on the device, you would see all the letters are wrong. Digits would be correct, but the letters would be incorrect. And because it's, even with the letter data, it's still not smart enough to understand the variation just based on the intelligence for the digit model. And so we have to talk about how models learn at this point. And so this GIF roughly shows what happens when an AI is actually learning how to find a particular letter or something. It goes through its classification space using a loss function. This gets a little bit deep, so I'm not going to go too deep into this, but again, this is my research background coming out. This loss function creates this landscape of intelligence, and there's an algorithm called stochastic gradient descent, which allows the model to hone in on this space to find out where the correct letter is. So this is what's happening under the hood. If people are interested in what the AI is looking at, it's something like this, and actually quite fascinating. And this equation on the bottom, which is called the gradient descent equation, is what makes all AI work, the current version of AI. So if you want more info, come talk to me later. But essentially what we did, I took the model that I showed you before, which was a very small model, and I increased the complexity of this model significantly. I added many more layers. I added dropout layers. I added special types of layers. I added 3 levels of dense neural network layer to it, and I added many more hyperparameters, other things to the model to make it much more complicated. And essentially what happens is that's still not enough. You have to actually find the correct parameter space. So on top of that, there's a process called cross-validation, which allows you to search the parameter space for the optimal models. This is called stratified k-fold cross-validation. This is the code for this, and it allows you to find the best optimal parameters to make your model super smart. And so, again, this takes a lot of work, but essentially a lot more processing power, but the model achieved a 91% validation accuracy on the MNIST data set, as opposed to the smaller accuracy. And so again, the GIF might not play, but what I would say is that you can, on the actual other slides when I share them out, you'll see all of these GIFs that the letter recognition is almost perfect here. That on the crosswords I can enter whatever letters I want, and then the letters get rendered in almost any variation, small, large, whatever. And the model's still pretty small. And yeah, and so before I get to the conclusion of my talk, there's this idea of synthetic data. So we talked about synthetic data. In the world of AI, for anyone interested, there's a theory of like mode collapse, where if you add enough synthetic data to the world, and since AIs learn on the data of the world, they will be learning on their own generated data, and at some point all the actual intelligence will leave the data and create all the same characters or all the same collapsed modes, and there won't be any learning. That's a grandiose kind of theory. We actually wrote about that at the times, but the point is that there's nuance into that, and there's not, for models like this, any risk of that. So synthetic data is actually a very powerful technique in the world of machine learning and model building to actually create larger data sets for your model to be smarter. But the visual on the right is approximately what it would look like if mode collapse occurred on the system that I'm showing you right now. There's the article in case anyone's interested. And so the next steps are basically enhancing the model and doing things like adding strike to replace or strike to erase. We can do that because on Android we have this whole concept of the Android Private Compute Core, which allows you to download more complex models and do on-device fine-tuning. Fine-tuning, I don't know if anybody's ever heard of fine-tuning here. If you're into AI, you know what fine-tuning is. That means that on the device, the handwriting style can be changed, so it can actually learn your particular handwriting style, and the model can change its intelligence. So even if you have a really crazy handwriting style, it will pick up what you're doing. And essentially, the advancements in that is that I showed you the convolutional model. We then moved to the vision transformer model, which is the current version of this model that can do much more interesting recognition. And so again, this is like, now the last caveat I would make is that all that we did was to essentially learn how the structure of machine learning would work on device. But if you use the digital ink recognizer that comes with Google ML Kit today, you can see that the model, without much work like what we did all those months ago, is needed because the recognition is actually really good. And it's not perfect, but it actually allows you to recognize different styles, different languages of letters, different types of characters, and whatnot. And so I put up a sample GitHub project for anyone who wants to try this out of how to do that. And one of the things that I normally talk about with AI is that you need to QA what happens in AI. So I also built a tool to QA any letters that are incorrect to make the model smarter. So if you want to re-download a model or improve the parameters of the model, you can use the QA tool on the device that I coded here to do something similar. And this allows us to do things like more advanced self-training. As you can see, it can find out which letters are more accurately or less accurately displayed here. And so basically, that's basically it for the talk. As far as there's more detail and whatnot, but yeah, thank you.
Ready? Okay. All right, thanks for joining, guys. So when was the last time a 20-minute presentation changed your life? Never? Then you were in the right room. If there was, then this is going to be even better. So welcome to day 2 of our Come to Your Core conference. That's me. If you want to connect with me, you'll get a free donut. I'm just joking. So there's been about 100 plus sessions so far. Most of the sessions kind of scared the crap out of me because I'm gonna take you to the why. So you got to remember, AI is everywhere. So my 65-year-old parents, who took 1.5 years to learn YouTube, now they're masters of ChatGPT, right? They go to a doctor, take the report, upload to ChatGPT, and then they're going to ask, hey, what should I do? Am I feeling okay? So everybody, the point is, everyone is an AI expert these days. Now, what most important is, how do you make sure the AI is secure, safe, and trustworthy? So this is my 4th or 5th presentation in the last couple of weeks. So I was on a panel with Forbes and Gartner. So most of the conversations kind of scare crap out of me because I'm more focused on security. So I've been an engineer for about 20 years, a state engineer. I think that's the best thing to do in the current world. Before I start, I want to give a shout out to Mr. Jerry. He spoke yesterday in this room. If you haven't watched his session, I would recommend you to go back and watch his session. So he focused mainly on what it takes to be a modern full stack engineer. So if you are a beginner, and I would recommend you to start there. So I'm going to deep dive into one of the critical aspects from his presentation, which is security. The security is going to be key to build trustworthy systems. So let's deep dive into it. So we're going to talk about AI security, and does it matter? No, it does matter, but let's see how. And how is the security landscape is shifting? And how do you do secure by design, and what is the significance of it? And tools for AI security, and as an engineer or developer, what you do to get into this roadmap. So why AI security matters now? Because AI is everywhere. Everybody is using a tool. Everybody is an AI expert. Everybody is using an AI tool to develop code, to test code, to deploy code. So it's everywhere. So the engineers are slowly becoming consumers. We should stick to being a creator. We're not consumers of tools. You can consume tools, but you need to understand what is the tool. You need to fully understand. Don't just focus on the output of it. Just focus on how they are doing it. So that's very critical. So I don't focus on how. Most sessions are focused on how, but I'm going to focus on why we should do it, how we should do it, and when we should do it. I think as an engineer, you want to stay as an engineer. You want to develop the engineering mindset. I think this is very critical. You want to be a developer, focus on how. You want to be an engineer, focus on why, what, and when. That's my personal motto. So the FBI Internet Crime reported that AI-powered attacks are 3 times more successful, and 1 in 6 breaches in 2005 are AI-driven attacks. And this is just the beginning. The AI revolution just started, right? I'm sure by the time that report was presented, but today it must be 10x or maybe more than 6 out of 6. So we don't know yet. So what is happening is everybody is using AI, and what will happen eventually is the AI components are going to be a layer in your application, the whole application setup. But that layer will either dominate or control everything else, right? With or without your knowledge. I mean, the engineer's knowledge. So they'll become, the AI is going to become the standard components in your application. And when we say AI, we are referring to a model, right? It's always a model. If there is no model, then I don't know what AI we're talking about. But so the ML models, they're embedded into your backend services and your LLMs, of course, in your user workflows and computer vision and computer applications. The AI use cases are very finite. I don't know how many of you observed. The number of models that you can use, the number of use cases it can solve is very finite at a principal level. So these are the top three that what I've observed. So any vulnerability in that AI space is going to cause a catastrophic failure for your application. It's going to bring down the whole damn application. So the pink fluffy monster that you see, that's your application trying to embrace AI. Now if something goes wrong, that monster is going to be angry. So landscape, how is the whole security landscape is changing? So the security is always a slippery slope. There's no end to it. When it comes to AI, the traditional application security is inadequate because the traditional focuses on your network, your code, your infrastructure. But when it comes to application security, it's going to bring new attack surfaces like the model. The moment you introduce model in your application, Gen AI model, it's going to increase the attack surfaces like model manipulation, like data poisoning, prompt injection. These are just examples, very popular examples. Now, as an engineer, I said developer, but again, I prefer to say engineer. So as an engineer, what's our responsibility? Our responsibility, security is no longer an afterthought. Security is not a responsibility of a platform team or an identity access management team. Everybody involved in the application has a shared responsibility of security. So the security starts with every single teammate in your team. Okay, now that's going to happen, right? That's an incident that is bound to happen. Now, what is the teller scared of? Is he scared of the banana or the robot holding a banana? What is it? We don't know. That's the state of incidents going to be. You don't know what is hitting you, who is hitting you, but somebody is hitting you very badly. So some of the examples are adversarial exploits, like a slight modification to the inputs. They can alter the behavior of your model. They can dictate what your model behavior is going to be. So that's extremely dangerous. Now data poisoning, if your data is crap, the model output is going to be crappier, right? That's period. So if I poison your data, then no matter what model you use, from whom, it's going to mess up the whole record. So data poisoning is key. And insecure endpoints, I'm sure most of the engineers are very well aware of using APIs, but if your APIs that you're exposing are not secured, then your business is down to dogs. So, all right, now what can you do to embed security into your application lifecycle, right? So that's called security by design. It's getting popular these days. You might have heard shift left. So shift left in terms of security, take it all the way to the design phase. So those are the typical lifecycle stages: design, implementation, you test, you deploy, and you push it to production. Now let's take design. So what can you do in terms of design? Like threat modeling. I don't know how many of you have heard about threat modeling, but threat modeling is going to catch at least 50% of potential vulnerabilities in your system. So I will show an example of threat modeling. Then in the implementation phase, you got to make sure the security controls are built into the models. Sometimes the model might have access to more than what is required, so you can constrain the behavior of a model, so which you can do that. And in testing phase, red teaming. You may have heard about penetration testing, but penetration testing and red teaming are like, they're brothers, but they're not twins. So I prefer red teaming than penetration testing because the scope is different. So if you're using a model, building a model, make sure you perform red teaming. What red teaming does is it attacks your model with a set of, with the attack library. It keep attacking your model and it will tell you before you go to production that, hey, your model is vulnerable in these areas. You know, so it gives you an opportunity to fix your model. Deployment phase, make sure the verified code or verified model gets to production. So before you commit your code or your model to your Artifactory or any other repository, make sure it is tested and verified, and only deploy those model or that piece of code. Now production. After doing all that, you deploy your application to production. It's out of your hands. You have zero control. But that's where the most damage is going to be, because it's AI. You have to monitor every single interaction with your model or with your application. how can you tell there is that a user with malicious intent is trying to tamper the behavior of your model? You cannot tell unless you monitor every single token, every single interaction through a token or a user, and you have to block that user or session or a token. So that's extremely important. Then threat modeling, I'll give you an example. So that's exactly how threat modeling feels. You don't know, you don't have your application, you're blinded, right? And then you have to design it, right? And you don't know who's watching your design. So I'm going to give you a quick example of the threat model here. So that's how the typical threat model looks like, and you can use Microsoft Threat Modeler. It does a fantastic job. So just put in, hey, I'm going to use a browser. Just drag and drop a browser in it. It's going to tell you what are the possible vulnerabilities that the tool is aware of. It's going to tell you how to remediate and all that. So that's an example of it, and you can just build crazy diagrams. So before you do, when you're designing your application, this must be the first step for any engineer. So the way you do it is you identify your key assets, be it a mobile phone or a browser or APIs or whatever, and then that will help you to map out the attack surfaces, and the tool will tell you for each of these attack surfaces, these are the possible ways that we can attack you, and you can assess the risks and then plan accordingly. Now, how do you secure your model supply chain? I mean, this is extremely critical in the AI lifecycle. Data acquisition, everything is revolved around data. If data is crap, then your model is, I mean, there's no point, right? And the model development, so make sure your data is safe, you clean it, and you maintain the versions of, maintain the document data lineage. That's very important. Model development and say dependency scanning. So you have your model, you develop your model, that there will be some dependencies. Make sure you scan the dependencies, look for all the vulnerabilities before you push it to repository. Then model registry, always maintain the version of the model, obvious reasons. And when you deploy, again, runtime protection. Runtime protection is when you monitor the interactions with your application in the runtime. So make sure that is in place, and then of course the container scanning is typical application security step. Hardening your AI APIs, again, this should be pretty fundamental for any engineer. Like you got to authenticate, authorize, make sure all input is validated and sanitization is done. Control your output, and then put some rate limiting and quota management. And it's pretty basic, but again, that must be there. So let's move on to testing. Adversarial testing for your AI models. So evasion attacks, model inversion tests, and prompt injection testing, that's something that you have to do in your dev. You do those tests, run those tests. There are tools which can help you to do those tests. Do those tests, and before you put it in, check in your code to repository. Then once it goes to production, the runtime monitoring is going to look for anomaly detection, performance monitoring. So anomaly detection is about suspicious activity that's been going on. It's very, very challenging to monitor that. So you can rely on some of the popular tools. Performance monitoring, it could be one session, could be hitting your system continuously or trying to steal a lot of data. So you got to look at the performance for sure. Access auditing, who has access to your system, right? The APIs that you're exposing, so make sure they're all properly authenticated. Then automated response. Now, this is very important because you do detect an anomaly or a malicious activity on your system, but it should tell somebody. So detection is not enough. You got to communicate back to the owners of the application so they can do the necessary action. So that has to be fully automated. So you guys have to configure it as an engineer. That's extremely important when it comes to the AI systems. These are some of the tools. I'm not a big fan of these tools because tomorrow there could be a new tool doing something better, or there could be just one tool that can do everything, right? So some of the popular tools are MLflow. I don't know if you have used it. Again, Prometheus, Grafana. Somebody was here yesterday talking about it. So, but the key thing when it comes to tools is at least what I look for when I try to implement a tool is I talk to the vendors and find out their research capabilities. Because this is AI, evolving space, if they are not doing the research on their end, then that tool or any tool is prone for attacks. So that's something that they have to establish, provide the confidence to me as a user that, okay, I'm going to use your tool. Now tell me what are the researching, what research, how big is the research team, and what do you guys do to identify threats on your tool? So that's something I'll make sure I always do that. And roadmap. So as an engineer, what's going to be your security roadmap is you start small, right? You begin with threat modeling for your current AI projects or your applications, map out your attack surfaces, find out how vulnerable your application is, and then put in your mitigation steps, right? So some of the tools, they detect the vulnerability, they'll let you the potential vulnerability, and they'll tell you what to do as well. So Microsoft Threat Model, again, I found it very useful, but there are other tools as well. Then build skills, of course, right? You got to train your development team, yourself, your dev team, on AI-specific security risks and secure coding patterns, right? So the secure by design concepts that you've learned earlier, that's something that I would hope you would implement in your projects. So I've been socializing this for a couple of years now within my teams and within my company to bring that awareness, which is extremely critical. It's always easy to fix a mitigate and vulnerability before it goes out to production, right? So catch it before rather than after. Then integration of tools. So add security scanning along with your code scanning. Again, I just focused on security scanning here, but the code scanning tools, that's SEA tools, or SAS tools, or DAS tools. So the AI security tool should be one among them in your pipeline. So make sure you have a job for AI security, and you do your code scanning first, then run the AI security scan, and then publish your code. Then the publish your code. Yeah, the next one is mature practices. As you do it more often, you should also on the side develop a comprehensive standard to implement security in your team or in your company, and then governance for all AI systems, especially when it comes to runtime protection. So when you detect something, how are you going to react? So that's something that you will have to implement. And yeah, that ends my my talk on this. So always remember, commit the code. So securely committing the code is extremely important. And with that, I'll take a leave. Thanks so much.
good? Okay. All right. Thank you, everyone. My name is Wayne Jones. I'm a senior software engineer at Capital One and an inspiring developer advocate. Have over 12 years of experience as a software developer, and I'm an advocate for making accessibility a priority in the web development process. Now let me talk to you why accessibility is important. Did you know that according to the CDC, 1 in 4 adults in the US live with a disability? And accessibility isn't just for permanent disabilities. Think about someone with a broken arm or someone that has eye strain from looking at a screen for too long. Accessibility helps everyone. Having an inaccessible website excludes people just as much as a physical location that has steps at an entrance. In a way, excluding a person digitally is in a way a form of discrimination. And in the United States, companies could be held liable for failing to create an accessible website, and we're seeing more and more companies being sued for accessibility violations. Even in some states, there have been bills that have been introduced so that even individuals could be held liable. Luckily, in this, none of the states have passed a law like that, but it has been discussed. So I don't know about you guys, but I want to save money. I don't want to get any lawsuits. So when thinking about web accessibility, it's good to keep in mind the 4 principles of accessibility known as the POUR framework. The first of which is perceivable. In order for things to be perceivable, the information on the page must be presented in a way that is not invisible to all the user's senses. Some users find it hard to read, view, and even hear content. In such cases, there must be alternative ways for the user to perceive that same information. For example, using text alternatives for non-text content, such as images, providing captions for multimedia video, and even providing correct color contrast can help the user perceive that information in other ways. Second is operable. In order for things to be operable, the user interface must be designed in a way to allow users to operate it. The user interface cannot require an interaction that the user cannot perform. So such things such as having time-limited interactions or user interfaces that only have actions that are accessible via mouse are not, in a sense, operable. Some examples on how to make things operable is to allow the navigation of a UI through keyboard. Allowing users to know where they are on the page, as well as using semantic HTML is vital and can help out with operability. Understandable. In order for things to be understandable, the user must be able to understand the information on the page. Using acronyms and jargon might be confusing for those that are unaware of the meaning behind those acronyms. Providing helpful error messages, using plain language, and adding more descriptive text. So instead of click here, you can say navigate to this page for more information. And adding labels for input fields would make things more understandable for that user. And lastly, robust. In order for things to be robust, the content must be able to be reliably interpreted by a wide variety of user agents, including assistive technologies. As technologies advance, the content should still remain accessible. So using semantic HTML can ensure compatibility with current and future user agents, including assistive technologies. And if you have to, you can also utilize ARIA roles to enhance accessibility where native HTML falls short. So now that we covered the 4 principles of accessibility, let's dive into some practical techniques that you can use in your React applications to improve accessibility. While this is in React, these techniques can be applied to any web development framework or library. So the first, semantic HTML. using semantic HTML elements is crucial for accessibility. For example, you should use a button tag instead of a div tag with the role of a button. This ensures that accessible technologies can correctly identify the element and provide the appropriate functionality. Focus management. Managing focus is essential for keyboard users. In this example, you have a modal component that takes in the props is open, which handles the visibility of the modal, and then on close, which handles the function of closing the modal. When a modal opens, you should set the focus to the first interactive element. In this case, it is the close button. This ensures that users can easily interact with the modal without having to navigate through the entire page. Granted, using semantic HTML, there's a tag called the dialog tag that you can use to do the same without having to do your own logic for managing focus. ARIA roles and attributes. ARIA roles and attributes can enhance accessibility when native HTML elements fall short. Let's say you have a drop-down list box that takes in a label and options as props. You have a button with ARIA has pop-up and ARIA expanded, which when clicked on would indicate and handle the drop-down state of the list box. The list box itself has the role list box for the drop-down menu, and each of the items within the list box also has the role option for each item. Keyboard navigation. Allowing your user interface to be keyboard navigatable would allow every interactive element to be reachable and operable. In this example, we have a component that has a tab panel, which displays content depending on which tab is active. We use ARIA roles here, such as tab list, tab, and tab panel for each of the different interactive elements. We also use ARIA selected and to tell the screen reader users that this is the current button or tab that is selected in the tab panel. We also use tab index to disable the interactivity of the other buttons that aren't selected in that tab panel. We also wanted to mention that, I already mentioned tab index, that we disable the interactivity of the buttons that aren't selected. And so in a way, since we are overriding the nature of the button, the interactivity of the button, we now have to create this other function to sort of handle the keyboard functionality. So we created this function called handle key down, and on key down, meaning the event, we essentially take the event that's fired, and if the event is either an arrow right or arrow left, we set the active tab state for the tab panel, and thus showcase the active tab panel that has the content. Now, there are some common misconceptions, common barriers for accessibility, and I want to go over that briefly. The first is time to market. Usually it's a race to develop a fast, viable working product, and accessibility is like the last thing that's on these companies' minds. Knowing how to test. One common complaint is that developers don't know how to test for accessibility using assistive technologies such as readers or tools. Time it takes to test. Another complaint is that companies say it takes a while to build for accessibility, but if you build a website with accessibility in mind, it won't take any more time to develop. And then the last one, why improve on things you can't see? Just because you can't visually see the changes doesn't mean it wouldn't impact the web experience for others. My motto for this is that, like, I guess my overall life motto is that we are all just temporarily abled, meaning everybody gets old, everybody will eventually have to use these technologies, so why not just build a website with accessibility in mind and also learn how to use the tools in the process. Yeah, here's some accessibility testing tools that I utilize, but while automated tools and linters can catch some accessibility issues, they cannot catch everything. It's important to also conduct manual testing when using screen readers and keyboard navigation to ensure a fully accessible experience. Now, advocating for accessibility. So when it comes to advocating for accessibility, there are 3 different things, and I'm sort of going to break it down. The first is you building the business case. Make sure that, like, when building that business case, that you're basically pitching the fact that with accessibility, you're able to expand that market reach. Think of that as like you're opening up your application or product to a whole different market of users, such as, let's say, for example, aging population. This also, a good thing to sort of recommend is that it reduces the risk of legal action. And it also demonstrates commitment to inclusivity and corporate social responsibility. Aligning accessibility with business goals. So in some ways you had to sort of frame frame this in a way where the business goals match sort of your accessibility, like, I don't know. I was gonna say, like, you sort of have to, like, sort of align your business goals with accessibility. Otherwise, like, otherwise you wouldn't have, like, business buy-in. So if you could tie that to sort of like a metric, such as like increasing customer satisfaction by improving the app usability through keyboard navigation, through other methods, that sort of builds up a case when it comes to pitching for accessibility. And then lastly, start small. You don't want a big, huge PR with thousands of lines of like trying to fix accessibility issues. Start small. Start with a small component. And then also what helps is you share wins with your team in order to build momentum. So that's sort of like I guess my ways I would advocate for accessibility. Now let me talk to you about an accessibility success story. So for me, a couple years ago, I worked for a digital agency, and Jovia Financial came to us as a client in order to make sure that the website, jovia.org, was fully compliant. Their website was full of accessibility issues, but one area in particular that was the most hard to deal with was the navigational menu. The problem. So Jovia website, their CSS was built on Foundation CSS version 6. And the navigational bar itself was built from a component from Foundation, and it was inaccessible. Even though the website claimed that their framework was fully accessible, this wasn't the case. I had went on GitHub to see if other people were like aware of this accessibility issue, and guess what I found? This is what I found was a GitHub issue that was 4 years old at the time, and the maintainer was made aware of this accessibility issue after a lengthy explanation of why it was inaccessible. Unfortunately, the maintainers were firm in claiming that the menu was technically correct and that the actual fix wouldn't be a priority until version 7 of Foundation. So, the solution. So I had 3 different options to work with. The first was either wait for Foundation version 7 to come out. 2, fork Foundation version 6 and implement the fix myself. Or 3, scrap the foundation menu and create the mega menu from scratch. So let me break it down like these 3 different options and sort of like the different caveats I had with each of those options. The first option, waiting for Foundation version 7. So since this was a 4-year-old issue and it seemed like the Foundation version 7 was nowhere close to being released, it wasn't even like on a roadmap. Spoiler alert, 8 years later and Foundation is still on version 6 and it's barely maintained. So that was a non-starter. So the second option, forking Foundation. Forking Foundation version 6 would mean taking on tech debt and having to maintain this source code ourselves. And I didn't want to really put like us through that. And then the third option, building the menu from scratch, would take time, but it would also ensure that every element of the menu is accessible. And so the outcome, we ended up going with option 3 to build the mega menu from scratch. I combined using both automated tools and manual tests for my audit of the Jovia website. And it ended up with these results. The first result, improvement. Oh, thank you. Thank you, you can clap. The first result was we had an improvement in accessibility scores. In Lighthouse, it passed WCAG, or Web Content Accessibility Guidelines standards. We achieved a AA standard for that website. Number 2, scalability. This allowed the ability in the future, if Jovia wanted to completely move away from Foundation and take this navigational component UI with them. And then 3, business goals were aligned with tech and product goals, and it reduced the liability of Jovia from website accessibility related lawsuits. Yes. So, key takeaways, what I want you to take away from this talk. Once I mentioned, start small, pilot a high impact flow or component, measure and share your wins to build momentum with your team. Combine automated with manual screen reader and keyboard audits. Invest in reusable, accessible components and lightweight process changes for lasting impact. And then, of course, the last thing, accessibility has both a moral and a business win. Inclusive products reach more customers and reduce risk. So my call to action to you guys. Hopefully, when you go back home after the conference, definitely look into the project that you worked on. If it's a website, pick a small component and essentially do some audits when it comes to manual and automated testing for accessibility. See if your component is accessible, and then if it's not accessible, then basically implement a fix for that. And so that's my call to action to you guys. And then let's collaborate to make accessibility a priority in every project. Thank you. Yo, since I have time, let me take a photo because I need to do this. All right. Thank you so much. Yes.
So what are best practices for not hiding things from screen readers? So I have a specific problem in Studio Code. We have a panel, we have an extension basically. We have to narrow it. And so in the chat area down the bottom, we have to take icons off. So I've discovered SRO.
Yeah.
Is that the best thing to use, or is there something better, more best practice? I'm not a React developer, so.
Oh yeah, for me, there's someone calling me for some reason, I don't know. Live talk. Anyways, yeah, I know, it's crazy. So yeah, the best option would be to utilize screen reader only classes that makes it invisible to the visible user, but it allows the screen reader to access that element.
Let's take all of our hidden tags and replace them with SRO.
Yeah.
Is it pretty much a one-to-one replacement? I mean, of course, functionality goes away. But
Correct.
Is that true?
Yeah, that's correct. Yeah.
And are there a whole class of SR classes in, I think it's in tail, I'm not a web developer. I'm like fixing this stuff and I'm like trying to figure out what I need to do. So,
Yeah, I think for, and I guess someone can correct me if I'm wrong, but I believe Tailwind has an SR only class.
yeah, it does.
So I would utilize that as a
There's
replacement.
whole other set of SR dash XXX in Tailwind to go look at to see other places that we might improve.
Well, I'm not fully aware of that, but
Okay, all right.
yeah, that's it. Maybe we have like time for one more question. We got 5 minutes. Okay. Yes.
So I saw in the talk, you mentioned the use of ARIA menu roles and how they were misused, and I literally had this exact problem last week. So we had like a drop down that was using the ARIA menu role for site navigation, and it should have been like a disclosure or something else. So my question to you is, like what accessibility tools did you use? Did you use like a tool to find that it was using the wrong pattern, or is it one of the tools mentioned up in the presentation?
Yeah. So I guess for people on the live stream, so the question is, how did I find that accessibility issue when it came to the Jovia website? And so one of the tools that we utilized was Site Improve, and that sort of flagged to us that the menu from Foundation was inaccessible. Yeah. So I would recommend like utilizing tools like that, Site Improve. There's like Ghost Inspector as well. Yeah, I'm like, there's a lot of tools out there to sort of detect accessibility issues. Cool. All right, we have 2-3 more minutes. Yes.
What do you use for automated testing?
Automated testing. For automated testing, we utilize I guess currently at Capital One, we use Invice for accessibility testing, and then we utilize for like unit testing. I guess it varies based on team, but we use Storybook tests for everything. They have also accessibility add-on that also manages and runs like a suite of like different checks for accessibility. So I'd recommend that.
Awesome, thank you.
Cool. And one more, yeah.
When you're line host testing, I know 100% is like the ideal score, but if you can't exactly, get to 100%, would you say 90 or above is like the best range?
Yeah, like my whole thing is like, I guess again, answering the question, if you can't reach 100 on the Lighthouse accessibility score, having some accessibility is better than no accessibility. So if your score is like a 90, that's good enough. If it's 100, even better. So that's what I would say. All right, I think we're out of time. So thank you so much.
Thank you. So yeah, hello everyone, welcome. Thank you so much for coming to the talk, really appreciate it. So yeah, basically we're gonna be talking about securing AWS environments with Terraform, Vault, and Veeam, which is some pretty cool tools, and we're gonna do a live demo, time permitting, either with Terraform Vault, and then if we have time with Veeam. So this is basically the agenda. We're gonna be talking about securing especially secrets, tool overview, the architecture of what we're gonna be handling, a live demo, best practices, and then wrap up and questions after that. So a little bit about me. I'm Nick G. I'm originally from Colombia. I'm the father of 2 children. I'm happily married. One of them is a newborn that was born a month ago, and I'm already starting him on HTML for babies, which I really love that book. It's pretty interesting. I'm a board game aficionado, so if you guys love board games or have any recommendations, I love to chat about them. I have around 60 board games in my house. They're amazing, and my main stack, or what I love, honestly, talking first, is React. I love the cloud, and I love doing stuff for mobile. I've been doing this for 15 years, and honestly, I just love doing this. So why this talk? I'm actually talking about experience of stuff that really happened to me. So around 7 years ago, I got a comment on GitHub, public repo, something like this. Looks like I accidentally leaked one of the secret out of database password, and thankfully a white hacker caught it, and he just sent it to me. And honestly, I started panicking. I was working for a US remote company at the time from Colombia, and I honestly was a first for me, and I have no idea what happened. But it's a common practice that is starting to happen more and more about secrets or stuff getting leaked, either on Git repositories or getting leaked somewhere, API keys or whatever. For example, this is something that happened with Mercedes. They had a GitHub token accidentally uploaded to a public repo of libraries that they support, that they're open source, in October of 2023. And it was 5 months before somebody actually discovered it. It was discovered by Red Hat Labs, which is a security firm that is honestly pretty amazing what they do. They disclosed it to Mercedes, and Mercedes confirmed the leaked and revoked the token. But it literally took around 6 months for it to be discovered. Imagine how much info was leaked, everything that happened. So basically what we're gonna talk here is about how to secure that on the easiest, fastest, best way possible. Why is this needed? So basically, secret sprawl, hard-coded AWS keys in repos or pipelines will lead to accidental leaks and breaches. At first, I personally started coding in PHP and other languages. We used to hard-code stuff. PHP is an awesome language which you can do a lot of good or bad stuff because if you don't follow the standard. So that was pretty common, honestly, to do, to just hard-code stuff there. But right now with this new React, with these new frameworks, with everything that is happening, this can happen on the pipeline. So if you use Vercel, if you use any of these other platforms to deploy, you actually need to set up your secrets. And it's very easily for them to get leaked or something. We'll look at that in the diagram a little bit later. The other stuff is manual provisioning and drift. So why are we gonna use, for example, for our cloud infrastructure? Basically, once we start, let's say, for example, AWS, you create your account, then you go into EC2, I'm gonna create a server, you go to Lightsail, you go into something, but everything manually, it's really hard to track what you're doing. You end up writing the PEM key, or I'm gonna just use a password. Everything becomes a little bit harder when time goes on, and it's easy to get misconfiguration. So with this tool that we're gonna use, basically helps us version everything on GitHub, and it works honestly wonderfully. Even for small projects, I started using it for, I don't know, I need to deploy a WordPress server for something that I'm doing, and it just works, and it becomes easier, and especially to manage. There's also a backup gap, because imagine you can rely on AWS snapshots, even about secrets or whatever, but they don't have a policy, they don't have ransomware protection, which is something that can happen, and I'm also coming from experience on this. And the last thing is compliance and audit pressure. So when you try to get compliance or the ISO 9001, sorry, I know the name Spanish, not English, it's really hard, and you're basically gonna fail if you don't have any of this, the first thing they're going to ask you, where are your PEM keys located? Where are your passwords? Where's the database password? And if you have them, no, we have them written down, we have them in AWS secrets or whatever, you're going to get failed it. So this is the easiest way, honestly, and the fastest way to get it passed. And right now, with the age of AI, basically, this is something that we see a lot. If you run this query on GitHub, you're going to see people that accidentally put their OpenAI key with all these new vibe-coded apps and everything, and they basically get leaked. Somebody grabs them and can ramp up thousands of credits in hours. We sadly had that happen once, so like I'm saying, coming from experience, and it's not fun. Thankfully, OpenAI has, they forgive you one of those life cycles if it wasn't that much money spent, so it happens. So the tools, what I honestly wanted when I first saw this, and especially being most front-end heavy developer, mobile heavy developer, how can I automate this, which will be the easiest, the fastest way, honestly, and the most robust? So Terraform, honestly, was infrastructure as a code. You can create a server instead of going, through EC2, configuring the VPC, configuring a lot of that. It does most of that stuff either automatically for you, or you just do it on some lines of code. But it's literally 4 to 5 lines of code. So for me, it was the most consistent and had the best repeatability. So if you needed to duplicate your infrastructure in another zone, you needed to move even cloud providers, it was super easy to move. I also like Vault. It's from the same person who bought or licensed Terraform, HashiCorp. And I love it because they have a free and open source, really, really good version of Vault that honestly, you don't need the paid one unless you're super enterprise. So they have for small, medium, large companies, solo projects, and you can just deploy it on any cloud provider for like $5 per month, or even running it locally like we're gonna run it. And Veeam, it's a great product where you can do a backup of the backup. So with Veeam, you're literally ISO compliant for all those certifications. It backups everything into an RDS instance, and it does it automatically against ransomware, against everything. So it's basically a win-win. So right now, because due to the time constraints, we're gonna focus on Terraform and Vault, and we're gonna try to see if we can squeeze Veeam in or just look at the configuration. So yeah, like I was saying, a little bit of Terraform. It's a declarative way to define AWS resources. You can define almost everything, users. You can enable version control, so you can see on GitHub what happened or whatever, or you're in a Git. And it eliminates manual console setup. I honestly loved AWS manual setup, like going through the console. It made me feel, I don't know. Right now, I personally dislike it. With this, it's so easy to create something and to destroy it with one command to save money. So I just go with it and integrates with Vault and Veeam modules natively. You don't have to do anything. So a little bit of what Terraform does. You got templates, scripts, policies. You put it through Terraform, and you can configure the network, security, application, cloud infrastructure, and storage. It's that easy. It has full power. You just need an AIM key, AIM secret, and that's it. And Vault, it stores sensitive data. So I want you to think of API keys, secrets, DB passwords. It stores everything on an easily, securely way that just works. You can also have dynamically short-lived credentials. For me, even testing it, you can have credentials for less than milliseconds. For 10 milliseconds, it generates it, then the CI pipeline reads it, and then it gets automatically deleted. And it does everything for you. And it helps really good for Terraform or really big workloads when you have like Kubernetes or really stuff that needs the bare metal power or the power. Remove secrets from code, repos, and CI environment variables. Personally, and I've seen it happen, for example, a developer gets his laptop stolen or something, leaves it open. They go into Vercel or something, and you can see the tokens, you can see stuff like that. This basically removes everything from the pipeline, everything. All the secrets will be safe inside here, and everything will get auto-configured. And it has audit logs for compliance. Auditors love this. If you go into the enterprise, they will literally know that you have Vault and this, and they will literally pass you really fast. So also something that happened from experience is we had a developer with secret files, the code repository. The code repository encrypted this on the CI/CD, and it went on the pipeline. But what happens the developer didn't have access to the production database password due to security stuff, due to compliance, due to how leadership is structured. He simply, on the files of the code base, where the lines are, he added like console logs or stuff like that to extract all that and get access to the password and leak it. So that's also that you can have inside I know he was crazy, but yeah, if you're watching me, I forgive you. But it ended up being a lot of work or whatever, but sometimes the attacks can come from the inside. So this fixes all of that because you don't need an infrastructure team, but everything will be handled for you and everything will be like kind of secret, secure. So that's why we also went this route. And this is basically also like what Vault does. It works with any cloud, with Azure, Google Cloud, with Kubernetes, directly with GitHub. So you got a lot of that, and you can even store databases inside of it. So more like imagine Mongo, imagine Firebase. I personally like Firebase a lot. It's very similar. SSH keys and even OTP passwords if you need to generate all of that. It handles everything kind of automatically with you and it syncs with everything. And all of this is with the free version. For the enterprise, you just need compliance or higher quotas. That's what you get, or you need support. And they're very generous, honestly. So I was like, okay. And last but not least is Veeam. But basically what this does is back up all of this into an RDS instance that is ransomware resistant automatically and basically backups everything. So it's a neat product, honestly. It takes a while to configure or to synchronize, so maybe we just fire the event and it will take around 30 minutes to do, but it's like the last piece of the puzzle, like full backup of the backup of the backup. So this is basically the diagram of what we're gonna do right now. So you have your code here, and we have Vault access code. The Vault will literally read all the secrets, and then it will either send them to GitHub, send them to AWS, and then Veeam will create a database instance and save it. And everything like of that will be parallel to the CI/CD process that is used by Terraform. So everything running in parallel or running separate gives us the security and the not headache that we need. And honestly, it's super easy. So this is the demo that we're gonna do. I'm really hoping, praying that everything works perfectly. So AWS, but we're gonna run Terraform locally. I already configured an AWS Sandbox account, and then we're gonna see if Veeam, a Terraform provider. So the first thing that I wanted to show is once you are in AWS, you need to create an IAM user and attach the policies. For example, I attached the RDS full access so it can create, delete, configure an RDS instance on MySQL or basically anything, and I added administrator access so it can create other users. Basically, that's the only thing you need. This will download a CSV that will have the access key and the access secret, and that's what you need to configure on the AWS. But this is basically everything that we need here. And just as a disclaimer, for example, you can, in DigitalOcean, you have a one-click deploy of HashiCorp Vault. So it's fairly easy. You don't need to configure anything. You just create an instance, and everything is pre-configured by you. But starting with the demo, so I'm going to create a new terminal, new window. Perfect. Let's make it bigger, like a lot bigger. And I have my notes here. So yeah, the first thing that I have running locally is Vault. So I'm gonna check it's actually running Vault version. So we have Vault version. This is the open source one, and you can see was recently updated, so that's pretty good. And the next thing is I need to see if Terraform is running. So I'm gonna go on version, and yeah, we have Terraform running. So that's great. So the first thing, I'm gonna start the Vault server. So it's literally running Vault server dev. Oh my gosh, already in use. Interesting. So let me just go ahead and close all the terminals, run them again. And let me see if it's actually running here. Okay, it was already running. That's interesting. The thing is that Vault, I think, is process kill Vault. Let's just try to see if we can get the token here. Okay, so that was a setup. Basically, a setback. Vault creates a UI for you so you can access it, but I need the token that it actually outputs. So, let's see if the fastest thing would be to restart. So let's see if we can do that right now. But I have a lot of stuff. Oh, sorry, please bear with me, guys. Let me see what else. That's actually a great suggestion. Thank you. Let's see if this is has something that is still running. Yes, it is. Thank you, sir. Appreciate it. And let me force quit it, and let's go ahead and run a terminal. There we go. So thank you so much. So this is the first thing that we need to run. We basically are running Vault in a dev environment sandbox that as soon as you close it, it's going to close everything and basically delete everything. So this is something that generates on the first run, that is root token and an unsealed key. The unsealed key, basically what I've seen companies do, is they just put it on an envelope and they put it like on a safeguard because it's like the master key. But this is the one we need. So let's go ahead here and reload, and this is the token we can use to access. So we can use Vault either through the CLI or through the web interface. So this is just the normal web interface. We create two places like the secret and cubbyhole, and you can then see, have access, the policies, have a lot of stuff. But let's just focus right now and create a new what do you call? Terminal. So I need to paste this because we're gonna export our global Vault instance, and then we need to export the Vault token, which is what we're gonna use so Terraform can actually see it. So let me go here, copy this, and and let's have it. Okay, perfect. So that way, in a new terminal, we had that. And how do we store the secret? So we can use the UI, or we can literally just run commands. And let's do Vault kv put. And which database are we going to do? We're going to use the secret DB. And let's call it password. This is the password that we're going to use to create the RDS instance. So let's go password equal my secure pass. And let's go with commit your code. Perfect. As you can see, here we just created it. And this is something important. It has a creation time, a deletion time. You can have tokens that expire automatically that are destroyed after certain access, and you can add any custom metadata. I personally always add who created the token, what is somebody doing, etc. And what if we need to get it? We just go Vault kv get secret, the access that we got db. And this is how it's stored. And in the UI, we go into the secret, and here you can see it. It actually ended up creating it. You can see it here as an admin. As you can see, we're here, whatever. So moving on, the first thing that we're gonna do is actually our Terraform thing. So I'm gonna be here, I'm gonna go into documents, Menkadir demo, let's go into demo, and let me go ahead and, let's go and create a initialize Git. I personally like initializing Git, so we can actually, keep track of our changes. And then let's send this to Visual Studio. There it is. So we can kind of have it. So really fast, because we have 5 minutes, I'm just going to create 2 files. I'm going to create the let me create main.tf. This is a pet peeve. I call it like this, so it ends up saving it. And I'm going to create that's another file that I'm going to create that is called Terraform. Terraform.tf-vars. Basically, those are the 2 files that we need to create our Terraform configuration. So I have this honestly, that I'm just gonna go ahead and copy paste it and explain a little bit. This is basically Terraform. You declare your infrastructure just with code. So the first thing is we need a variable that is gonna save from our storage the variable, the token that we need. So we declare here we're gonna say to Terraform, imagine the package.json that we have on front end. We're gonna say, hey, we need AWS and we need Vault. So we need you to install that. Then the provider, we're gonna deploy this on ES1. We can adjust it to any region. This is the Vault, so we're putting the server. If you guys see, if we click on this, it's the local server that we're running. And you are gonna need to take this, the Vault token. It takes the secret from the Vault. I'm gonna put this all in a blog post so you guys can just copy paste it or run this again. And this is where we declare. I need you to create an AWS instance that has 20 gigabytes of disk. MySQL is a dbt3 micro with admin, and here is where we inject the password. As you see, we're not having anywhere any password. It's gonna read from the Vault and put it, and the output is if it does. And the only thing that we need to put on this file is what it needs to do. So Vault token, and we need to actually add the Vault token that we created here. So let's go ahead and do that. And that's it. Literally, that's what we needed. So the first thing that we can do to run this is go Terraform init. Oh, Terraform init. Now it's gonna go ahead and find, it's installing HashiCorp AWS, it's gonna install HashiCorp Vault and everything, and the next thing is gonna be literally Terraform plan. This may take a while, so I had a backup of the backup. Oh no, that was super fast. So it was just initialized. So the second thing we're gonna do is Terraform plan. And what Terraform plan is, it's like a dry run. It's gonna check if you have access to AWS, if it has access to the Vault, if it has access to everything. And look, it says literally, you have access to everything. You can create this, everything. This will be created. And if you want it to create it, you just go Terraform apply, and that's it. It says, do you want to perform these actions? It's gonna create this, so yes. And ooh, we had an error of access denied. Okay, so then we will need to go into IIM console, see why we got error denied if we added the RDS access, and basically it will automatically create. So just to wrap up, as you can see, it's very easy to create something. What I want to reiterate is this is literally the code you need to configure the Vault, and this is the code that you need to configure Veeam. As you see, we literally just add a provider. On an endpoint, this will be the URL from the actual URL from database that will be created on the previous step, and then the resource policy, and that's it. Everything will be automatically configured to you. The only thing that we will need to change on this Terraform plan or code is how long we want the backups. So I will go here and basically just tell it, hey, I need you to back up daily RDS at the schedule every time at 5 UTC and keep after 14 days. And this will do everything for you. And that's it. This way you have secrets, you have backup of the secrets, and it just works and deploys with one terminal command. So that's pretty much it. So just to wrap up, because I have 1 minute, the best practices will be never hard code secrets in Terraform. Use this. Store Terraform state securely. You can save your Terraform configurations to S3, DynamoDB log. This is like a really secure way to do it. If you want like major security for any compliance stuff. Use least privileged IAM roles. As you see, the error I got was because of IAM policy, because I have the least privileged principle globally on this AWS account. And test restores, not just backups. So that will be the last thing. Always, always test restores. And yeah, that's the wrap up. We did infrastructure as code, secret backups. The next thing will be try it in a sandbox and then scale it to production. You can do it with your own home server. Your personal website will be an awesome thing. You can host it for less than $3 per month on AWS. And that's it. Thank you so much, guys. If you ever want, thank you. If you want to connect, this is my Twitter, this is my GitHub, and whatever questions you guys have, I always follow back everyone, and we can just talk and we're here to help. And that's it. Thank you, guys. And
about to kick it off for CYC 2025. That's why you are here. And then I should be able to point this here. And then I got this. I got 2 cameras. Life is good. How we feeling? Yeah! Penultimate talk of the day. Here we go. You are here for Data Gone in 60 Seconds, a serverless ETL story. So here's the story so far. Let's just get right into it. I love serverless. If you like serverless, make some noise. Okay, great, good, perfect. So that means I get to talk about the fun stuff, which is the terrible stuff that you have to deal with when you're building things. How to overcome this terror of having to build something with divine inspiration from the one true God of the internet, Nicolas Cage, and we will get to that. And just remember that all software is just a journey of trade-offs. Everybody here made a case for a trade-off they had to make. Every single talk is just that. So we'll start with there. Of course, we have to start with the business, because you got to talk to business in order to build software. So imagine you're going to a meeting with a holder full of steaks, and what does business want? You come in with your notepad. You're not exactly sure. It's about to kick off. And you learn you're going to build a data pipeline. You're like, cool, I love data pipelines. I build data pipelines all the time. You're not going to be able to control what data comes in. Okay. And then you have to actually do stuff to it. Okay. We want it in real time. Like real time? Like near real time. I'm like, okay. And I need you to store it in an external data lake that's outside of our network too, because it's going into another BI system somewhere else. So you're like, okay, what am I actually doing then? So once you're in that meeting with stakeholders, then you realize you have constraints. The data is coming out of like, you can imagine like an IoT sensor on a whole bunch of machines out in the field, and it's just kicking out updates all the time. And a totally different vendor, different business, they know how to install the IoT things, they know what the data actually means, they're part of the science of it. I'm just a lowly like cloud engineer. I give them an endpoint that they can shove their JSON over to. Then I want to transform the data, and then again, I gotta drop it someplace else. So, as I'm looking to myself and the rest of the team, I'm like, how are we gonna do this in like cost effective, meets all the criteria? And that's where we come to the power of Nicolas Cage. So this is the 2000s Jerry Bruckheimer produced movie Gone in 60 Seconds. Make some noise if you've seen the movie. Yeah, okay, all right. For those who haven't, it's about Memphis Reigns, a retired car thief. Amazing car thief, never caught. But then his brother's a pretty big bonehead and picked up a bad deal with a mobster who's in town. So then Nicolas Cage's character has to come back to save his little brother. So just like when I walked into that meeting with the stakeholders, I was like, all right, what does business want? Then you hear what all the constraints are, and you're like, business wants what? Memphis thought, yeah, I can help Kip. He's my little brother. I steal cars all the time. What's the big deal? You got to do 50 in a night. No way. No one's doing 50 cars in a single night, and that's the whole plot of the movie. It's like, how can Nicolas Cage steal all these cars in a single night? 1 car, sure. 10 cars, he could probably do it. He's superhuman at stealing cars. I build pipelines. Sure, I can do pipelines all the time. But what is the real constraint? And how do we make those trade-offs? So Cage, he's facing up against evil mob boss and some cops in the area just to save his brother from himself. So there we go. How do we solve this? Well, when Cage has to pull this off, he needs a crew. Like, a good chunk of the movie is a nice montage of building your crew, right? Same thing with cloud architecture. You just got to have a montage of building out your crew. Your crew is that infrastructure. It's like, what are the resources? What are the tools that we're going to use? And how is serverless like a bunch of car thieves? Well, I think it's good to think about like traditional servers are long-running processes. They're monolithic. But with a crew, you have individually responsible single units of work that can process things on their own independently. They don't have to go out all together at the same time. They can take off at different times during the night to steal the car and bring it back independently. It allows you to scale how many cars you're stealing without having to worry about always orchestrating all your thieves together. That's how I treat my cloud crew, all of my microservices and the things that I use from AWS. I put these bullets up in case you're trying to get a job as a cloud architect. These are the things that you can put as like stuff I know about, how to decouple services to avoid downtime. Everything is event-driven. It's the idea that you have a system of stuff that's waiting for an event to happen, and then you just process it after the fact. I love infrastructure as code, runs everything I do, and I think it's a faster dev cycle because I can work with real live endpoints that are in the cloud that are already deployed. And then, of course, abstractions all the way down. I realized, actually, in one of the previous talks, Brian talked about just how Netlify works and Vercel. So if you're already deploying on that, you're using AWS without realizing you're using AWS. So let's get into the quick architectures of it. So I have a third-party SaaS. It's going to send a post request to an API gateway that I have. There's a Lambda function attached to that gateway. It's going to take the JSON in, partition it by date to an S3 bucket, and then we meet the first super specialist on our crew, Toby. So Nicolas Cage, Memphis Reigns, he's putting together his crew. Everybody's going around saying what the best thing they can steal is, and then Toby's like, I'm good with computers. He's the youngest of the crew. This is the year 2000. He's like, I'm good with computers, and Memphis is like, what does that even mean? And his friend vouches for him. He's like, he could hack the DMV, and that's what he does, because it's the year 2000, and if you know computers, you can hack the DMV. So Nick Cage is like, great, we can find where all the cars are at, because that's one of the first problems they have. They have a list of cars they have to steal, but they're not sure where to get them from. So Toby here hacks the DMV and enriches all that information, finds addresses for them. In my architecture, I use this service called Athena. Athena is a serverless SQL query layer that you can put on top of any data that's inside of S3. So because when we ingested the S3 files, those JSON files, we partition them by a date, and that date partition represents tables and metadata that Athena and Glue can allow me to query on. So data's just coming straight into the bucket, and then at any time, our analyst can run an ad hoc query to match whatever's in the bucket. So Toby here, Athena, enriches our data, enhances it, kind of like hacks into it, and makes it better, makes it usable. So that's how we're filtering the data. Now, the other side, once Athena has filtered the data that we want, it does a little bit of a transformation. In my example code, we go from Fahrenheit to Celsius, and then it puts that data onto this thing called an SQS queue. It's a message bus, it's a queue. Messages come onto it, and then messages go off of it. Now, in the stealing of cars, while Nick Cage and all of the rest of his friends are out taking cars, they're radioing back into Otto. Otto's the old guy. He knows what's up. He's really handling the list from the global perspective. You know, if each thief could have their own list that they have to complete, but then each thief is not really decoupled anymore, right? Their only job is to go out and get the car that they've been told to get. They shouldn't have to know if that car was on the master, like as part of the master list or has already gotten it. That's Otto's job. He's back at base with the actual master list. So SQS is a way for me to handle the upcoming constraint of having to send this data and store it in an external data warehouse, right? It's outside of my network. So I don't want to overwhelm it, so I want to be able to batch it and throttle it before it leaves the queue. And then the queue is there to also make sure that we don't drop messages. One of the features of SQS is that they call it a durable queue, which means you're going to get everything at least once. And it's up to you to implement how you want to handle like deduping or errors when you push it. But in this example, this batch process, it's just constantly listening for messages that go onto the queue. So this Lambda here, I don't ever really have to invoke manually. So now what we can see is that we've taken in some data, found a way to filter it, found a way to batch it to its destination. And this whole time, I haven't really stood up a database at all. I've just been using an S3 bucket and some clever services on top of it because the system that we were building didn't need a permanent database. Like a lot of this data that's always being generated, most of it is within normal operating ranges. So we didn't have to capture everything and save it forever. They were just interested in the ones that hit their criteria at that Athena query layer. And another thing to note about Athena is it's really good at querying. So you can search over stuff that you've set up, but it's not, again, it's not a real database, so you're not like updating values or writing back into S3 with it. It's mainly just for looking at a whole bunch of data and then being able to query on it with SQL without having to instantiate another machine or create a Kafka cluster or anything. It just comes natively from AWS when you kind of do this stack. All right, 13 minutes. Whew, this is a good one. So first, I'm gonna ask y'all, do you believe in the power of Cage? Yeah. Yes, good, okay. Because now I'm about to tell you who I am. My name is Paul Chin Jr. I'm a solutions architect. I'm a solutions architect for Serverless Guru. We are experts in the cloud. We've actually got this really cool thing going where, like, if you want to have an engagement with us, we guarantee that we'll save you money on the cloud engagement, or like we won't charge you for it. So I think that's pretty cool. Just saying, just putting it out there. I also run the podcast. If you go to Serverless Guru blog, I got a bunch of cool content there. Do I have time? I got time. And then I've also got to tell you, on the internet, I have a project where I took a salad spinner and turned it into a DJ controller using nothing but JavaScript and WebSockets. That's another different talk. You can come find me afterwards, after we're done here. I got this stuff for days, folks. Like, this is all my brain does. So yeah, you can also find the code repo there. So this is the one slide I'm hoping you're looking at. Yeah, I know. Like, it's really good. I like this. This is an AI picture that I had made, but it was like handcrafted. Like, this is before. Because I did it like a million times, and I was like, shit, I got 5 fingers, I'm done. I know, but it's only 5, bro. Like, I gotta get it where I can. Okay, so demo time. On 3, I want to hear the loudest praise Cage ever. On 3, 1, 2, 3, praise Cage. That's right. Let's go. Okay, running in production. So now, all right. So this is an HTTP client. It's called Hopscotch. It's like Postman but better. So we're going to send a post request to the API gateway. Everybody with me there? No tricks up my sleeve. Here we go. And sending some JSON data. Whew, here we go. Wrote 6 records to S3. Sick. Let's go to S3. This is a bucket. This is your bucket on AWS. This is your bucket on AWS that just caught some JSON data. All right. Whew, first part's done. That's it. And then the second part is the Athena query function. So anytime I want, I just make this ad hoc. And I'm using the Lambda console here just for simplicity, but you could imagine this trigger being something from the front end, like you build a React app, and the analysts are going to pass in all of their favorite things to filter through, and you hook it up, and you invoke this Lambda, and the Lambda will run its logic, put the thing on the queue, and then once something is on the queue, another Lambda will automatically pull it off and post it somewhere else. So here we go. One button click. Bang, we're gonna hit test. It's executing. The Lambda is running. It's asking Athena for stuff. All right, so something succeeded, but we can also look here. This is X-ray. It's like a trace map for the functions and services that run in AWS. So let's refresh it and see what it sees. Okay, so this was the post request that came in to our API gateway and wrote some stuff to S3, which is in here. So we're looking at the S3 bucket. All right, I got a transformed, which means that the Athena function should now have run, yes, here. So when I manually triggered the function, it kicked off this, which then kicked off Athena, which then put the results onto SQS, which then caused another Lambda to post some data to this endpoint. And if I select star, should be 6 records in there. Hey, we did it. That's a full round trip. Hey, 6 records. I'll take it. And so, yeah, I can prove that it went through the system with traces and everything, and all the code is kind of natively done for AWS. But I wanted to show off Valtown. I talk about it a lot because I really love it. It's called val.town. You write TypeScript or JavaScript into it, and the entire external data warehouse endpoint is this file, main.tsx. Valtown has the ability to associate with a SQLite instance in Valtown. So this endpoint is just hooked up to a SQLite, which is, it gives me an endpoint like this, right? And then that's what I post from AWS. So it actually leaves the AWS network and comes into this network and gets written. So with this kind of setup, you can play with you could on purpose make this slower and then start sending stuff and figure out the right batching window you want. Because in SQS, you can batch up to 10 messages at once, and then there's a timeout window. So depending on how long your thing takes to process, you can actually extend the batching timing window from like a minute to maybe 3 minutes. And in those 3 minutes, you'll be able to process the full 10 records. But yeah, Valtown's really great for creating these endpoints. They also have cron jobs that are really fun to use. But basically, once I write it into here, then I'm just able to see the data again. So that was pretty cool. And we went through it like crazy fast. Dang, I went way too fast. All right, so here we go. It is data gone in 60 seconds. This is also, maybe I can give you all some time back. No, running in production. So this is the full architecture. I have, the third party coming into API gateway. As soon as that gateway endpoint is hit with that post request, a Lambda runs, shoves it in the S3 bucket. There is work to have to provision the glue thing. Maybe I can talk about that for like half a second. Athena is a service that enables SQL queries on a metadata catalog that AWS uses called Glue. So before you can use Athena, you have to tell it what data it's expecting, because you're writing a SQL query. So you have to kind of make up a table, and you have to map your data to something relational that you can query on. So when you're receiving this data, it'll be your job to try to figure out how am I going to put these into S3 that I can query on, and how will I map that to the metadata store in AWS Glue so that Athena can do its thing. In my example code repo, there is instructions on the Athena part, the Athena setup, right? This looks a lot like SQL stuff because that's what it is. You have to do this part after you deploy so that you can set up Athena, but once it's set up, it is like a database, but it's not a database. It's some fun software middleware that allows you to treat these persistent S3 objects like a database, which I think is pretty cool, because at no point during the time of this build did I ever have to stand up a real database. All of my IAM and access and stuff was just through service roles. So the worst thing I hate about databases is that one moment where you have to have the master account. It's database name, password, and that is somewhere. It can't be nowhere. It is somewhere, and that always keeps me up at night. But with IAM roles, they're just always ephemeral. They're checking in with the master, or they're checking in with the main service at runtime every single time. Way more secure. Way more secure. All right, and I guess while I'm in here, I could show you the SAM template. Make some noise if you know what SAM is. Okay, SAM is, you go watch his talk, because it'll actually do a really good job of explaining how to use AWS without AWS. And so SAM is a infrastructure as code tool that will turn this YAML into much larger CloudFormation. But the entire app that I'm showing, the entire pipeline that I have here, is defined as a bucket, the API endpoint, an API key, so it's authenticated, some accounting on that API key so that you can charge people for it, the actual data queue, the actual functions right there and there and there. So there's only 3 functions of code that I've written to do this whole thing. And when you deploy it, it deploys all this stuff for you. And a lot of it fits in the free tier. So even on AWS, if you're just playing around with it, you can do some decent stuff with just this. So let's go back to this final diagram, right? We got Toby the hacker. He's enriching the data. The crew is capturing the stuff, and then Otto's making sure that all the things are being checked off. And it's pretty much automated. Like, if I wanted to, I could script just like posting to the endpoint and then script the Athena client running on its own. I really don't have to do much of anything else. So for those that aren't like in AWS, there's ways to do all of this stuff in every other cloud. This is just, the idea is to not have to be precious about the underlying infrastructure specifically. Like, I don't really want to have to put together my own Kafka instances to handle messages. I really don't want to have to deal with like hard disk file I/O if I can help it. And that's really what it means to kind of like build cloud native, build serverlessly. It's about finding that value from the vendor so that you can just worry about stealing the cars, like converting the data to a format that you want. And by doing this with the infrastructure as code, like you can put it all in a CI/CD pipeline, you can deploy the front end and the back end all at the same time. Super cool, super clutch. It's the only way I've been building stuff in the cloud for the last 8 years. And so finally, with 2 minutes and 35 seconds left, did we learn something? Ah, yes, very good, very good. So I like to break up my talks into 3 different sections. For those that are brand new to this stuff, speed. There's from that QR code, there's a repo. Download the repo. Try to use it. It should run. If it doesn't, file me a ticket. You'll learn how to do pull requests. It's a win-win for everybody. If you're kind of intermediate, there's a lot of stuff you might be able to break or figure out how to start from my repo as a starting point and see if you could make it more secure, or if there are something about it that you could change to make it even better, even better. And then finally, for those that have been doing this for quite a while, I implore you to add narrative to your architectures. Like, I go into the room and I say, hey, we gotta fight these bad guys, man. Like, people can come together. Like, I got the cops breathing down my neck. I got these mob bosses on me. And everyone's gonna kind of know, that there's something more going on than just the code. And I think I've heard it from all the folks out in the vendor areas where I'm like, hey, what are you really looking for folks that are coming onto your team? And a couple of them said, like, we need people that can understand the business as well as the code, even more so the business. So if you're able to explain your code with narratives like this, it goes a really long way to be able to like get that political capital for you and your team. And finally, if you don't know what ADR is, it's an architectural decision record. It's like 2 sentences of why you did it. It's not a commit message. It's not a comment. It's an actual reason why you did something and why you didn't do something else. Just check it in with the repo. Those 2 sentences will save somebody 4 hours in 6 months. Promise you, if you start doing them regularly, you will be the 10x engineer. And with that, thank you so much. I got 40 seconds left. Yeah! And then for promo on my next talk, Better the Devil I Know sequel, a Ghostwriter vengeance story where two database paradigms battle it out for my soul. And with that, thank you all for being here. Really appreciate you taking the time. Let the conference know how everything was. Make noise on social media. I am Paul Chin Jr. everywhere, serverless guru. That's it. Thanks. Yeah! Oh, 5 seconds left. One more praise cage in 3, 2, 1. Praise cage! Done. Bam! Yeah, let's go.
Good afternoon, everyone. How is it going so far? I'm sure it would have been a fun-filled and packed day for all of you, and a lot of sessions for the last 2 days. And hang on with me, this is the last session of the day, and you're all set to go for the weekend party, I guess. Yeah. So I'm taking a different perspective today. I'm not going to show any live demo. I'm going to talk about how not to build a startup. And again, it's also related to AI. I'm going to talk about AI has changed the startup world, right? So AI has changed everything in startups, in coding, in development. So AI has changed the startup world. There are a lot of startups coming out of stealth every day. I don't know if you all follow news. There are a lot of startups coming out of stealth. There are a lot of startups getting funded every day. They're getting funded in the range of 50 to 100 million. Like last week, there are many startups got acquired for 500 million to 1 billion range. If you see in the left side graph, if you see the funding of VCs are not getting slowed down at all. There are a lot of AI startups keep getting funded and the graph is keep growing. On the right side, if you see the pink color graph, that's where the AI startups are getting funded fast compared to the non-AI startups. When you have a startup with AI, VCs are willing to skip a lot of due diligence and they're willing to invest in you compared to non-AI startups. AI startups are getting a fast pass, and there are a lot of AI startups getting into live and a lot of traction in the coming, in the last couple of months. Right? So what I'm going to, also if this is a recent article, the research that came out today, AI is getting normalized. There are a lot of tools being built around AI, and if you see this is a research where ChatGPT is able to do 50% of the practical tasks that a human can do. Like we take about all the practical tasks that you consider doing on a day-to-day basis and consider that GDP, ChatGPT 5, the latest model, is able to do 50% of the tasks that a human practically will do. So it's keep improving. The models are improving. There are a lot of agents coming around. There are a lot of tools being built around the agents. So AI is getting standardized, and it is easy to build a startup on top of AI models. Before it was really easy. Before it, like 3 years back, when we were trying to build something with AI, we were able to only get hands on Hugging Face or any open source models. But there are a lot of out-of-the-box agents, out-of-the-box memory tools available in the market to build startups. But I'm not going to talk about how to build an AI startup now. Today I'm going to talk about from 18 years of experience building 3 startups. I have failed in 2 startups miserably, and finally with Juggle, that is my startup that I have now, we are thriving, we got a market fit, and we are able to generate revenue. So I'm going to talk about the 3 lessons that I learned by building startups. So that will help you all when you are building a startup, so that way you don't rely on these mistakes, and it will help you to build your startup as well with AI boom, right? So Juggle, what is Juggle? So Juggle is an AI-powered workflow management application. We have users across the globe. We have around 250 businesses who use our app, and we have around 3,500 users using our application. So again, like I mentioned earlier, this talk is not about the success story of Juggle. This talk is about how not to build a startup. What are the lessons that I learned building Juggle? The first lesson, I'm going to talk about 3 lessons today. This is the first lesson. The first lesson is don't fall in love with the idea, right? So a lot of us have ideas, a lot of us want to do startups, but what happens when we try to execute them, we see they are failing, it's been failed, right? So we start with the idea, we think this idea is the right idea to execute, but once we execute the idea, we see no users are using our application, we stop from there, we don't continue building it. That's where here if you see a lot of pivoting is good. So every startup have to go through a stage called pivot. So if you have an idea, you start building it, but you see that idea is not the right idea to go, I would recommend you to pivot. If you see all the apps over here in the screen, for example, Shopify, it took 2 years for them to pivot and find the product market fit. So pivoting is not bad. But when pivoting becomes bad, right? When pivoting becomes bad, when you're stuck in the pivot hell trap. You don't know what you're pivoting to, right? So you're keep on pivoting. So you see some shiny objects, you want to build that. Next day, there's a VR glass introduced, you want to add that to your application. If you're pivoting without a goal in your mind, without getting feedback from your customers. So when you're pivoting, you have to go in the direction of your customers. You should have an end goal in place. The first step is you have to listen to your customer feedback. When you're pivoting, the second step is you should have a larger goal in your mind. Where are you going to heading to? What pivot? What is your app's concept? Like for example, when we built Juggle, when we built our software, we always want to build or solve the problem for small and medium enterprises. We want to solve the problem of operations management. So we always went to small and medium businesses and we got the feedback from them, and we always pivoted on the range of what small and medium enterprises wanted. So like here in this picture, There's one pro tip that I will give you. If you are closer to the problem, try to build around that problem, build a solution for that problem. So if you are not part of the problem, it's very tough to build. For example, we go and ask a customer feedback, we will not be able to understand what they are trying to tell us because you are not part of the problem. They might think something in their mind and they might ask you for something. A lot of times when we go and ask customer, hey, do you want to build this feature? Yes. When we go and build it and present to them, they ask for a different thing because they start using it, when they feel it, it is something different. So when you are part of the problem, it is easy for you to build. So if you want to build a startup, you should be part of the problem and you should experience that problem. It's easy to solve for you. So try to pick a problem that you are part of, so it is easy to solve for you and it will be also solved for many other people like you. So again, like I said, this is a funny thing. So we started as a chat app in 2020. These are the pivots we did personally, I did. So we had to go through these pivots. We started as a chat application in 2020. We released in 2021. By the time, communication was a bigger problem during COVID because small businesses could not communicate. All the businesses were closed. Everyone were virtual. So they couldn't communicate with each other. So we released a chat application. By the time we released, all the businesses started to come online and they started to go in person. Then we released a task management app. So all they said is, hey, chat is not enough for us. We also want task management built in. Then again, we went and asked the customers. Then they said, hey, we want attendance tracking as well. We want all the HR management to be done here. Then we asked them again. They said, hey, no, we want order management. Then what happened? Eventually, we built these silos inside our app. Finally, AI came to our savior. So now we have AI, which connects all of these features together. Now we are AI workflow management application for both small businesses, which are running e-commerce and social application, as well as to manage their operations. So all the time we were focusing on SMEs, how to help them manage their operations. Even though we pivoted, we built so many things, we were always going to our customers, giving the app to them, asking them for the feedback, and building based on the feedback. So pivoting is not bad as long as you're sticking to what the problem you're trying to solve, right? So that's the first lesson. Don't stick to your idea. Try to pivot, try to get your customer feedback and go in that particular journey. So next one, lesson number 2, which is don't neglect fundamentals for hypergrowth. How many of you have pets here? Can you raise your hands? Yeah, we are all pet lovers. I have a pet, it's a golden doodle. I miss him a lot. So yeah, yeah. So this is about a comparison. How these two apps failed. Like I'm sure most of you know about Rover, but not many of you know about WAG. WAG was a dog walking app. It got funded around 300 million at a 2 billion valuation in 2018, and they miserably failed in 2023. Like after 4 years, they got bankrupt. In 2023, they gone bankruptcy, and they are not no more. But similarly, Rover, they got funded at 3 million to start with in 2012, and they slowly built. They asked feedback from the customers. They built their foundation very strong. They were focusing more on the customer service, the quality of service, the output that they are providing, and that's where Rover got acquired for 2.2 billion, and then that investment firm listed Rover in IPO in public markets. And still Rover is #1 app for pet sitting. I use Rover as well. So what WAG focused was, as soon as they got the funding, they never focused on the customer service, quality, or vetting the sitters. There are a lot of problems when dog sitters were not vetted properly, the dogs were not taken care properly. So they were more focused towards marketing and sales before building the foundation correct. That made WAG customers to drop. So that's what nowadays they call it as product-led growth. If you go online, if you're building a startup, everyone advocates you for product-led growth. What they say is, you go, give your product, users use it, and they start paying for it. So no one charges for the apps if you see. So that's what ChatGPT did. That's a product-led growth. They give you a free version, they make you addicted to it, and then they make you pay for it. So there's no more paywall. Like 5-6 years back, you have to pay for something before you start using it. But nowadays, everything is product-led growth. So you have to build the app has to be so addictive that people will have to pay for it. That's what ChatGPT did, and we are all into the AI wave now. So it's the same. Every app does the same now. So get your fundamentals strong before the hyper growth, before you start marketing, before you start selling. But there is also a key pro tip here. How do you know there is a demand for your app, right? So you have to do marketing for it, but not by spending money, but by reaching out to all the communities. There is Reddit, there are many forums where you can go, you can give your app, test your app. When we started building our app, we had a big community of testers who test it. we know they will not be users again for us because they hate the app. The app was not ready. But they gave us feedback that your app is not working. So we had community, we built a community around it. So we asked our users feedback continuously. Okay, this is the other that's a good thing we did, but we also did another mistake. So we were a little bit greedy when we launched our app because it was a generic app, it was a small businesses. We know small businesses are everywhere in APAC, they are in Europe, they are in Middle East. So we thought, why shouldn't we go global? It's now online, it's virtual, so why shouldn't we go global? That's where we assumed our app can be used by every business globally, even though they are SMEs, but we hit a block there. Not just from customer success and sales, but also technically. I'll just give you 2 examples. One example is everyone knows Stripe. So we use Stripe for our subscription as a SaaS product in US. And we assumed Stripe is also a global application. It does payment processing across the globe, but no, it doesn't work in APAC. So we had built our sales team, customer success team there as well because customer acquisition cost was less, but Stripe is not working for collecting payments. So we have to collect payments manually and we have to integrate a different payment processor there. I don't think integrating a 2 payment processor is going to be a USP for our app, but we have to spend development time in integrating 2 payment processors. So all the users who are coming from APAC region, they will see a different price, they will go through a different payment processor. All users coming through US or other regions will go through Stripe. In the early stages of development, every hour, every minute matters. So that's where I am saying, so don't assume everything globally. So try to build the product locally, try to give it to your customers locally, try to market, try to find the market fit before you spend on certain things, before you try to scale it or market it globally, right? Second thing is we always thought the businesses run same in every place, like SMEs are SMEs. But no, that's not the case. When you look at a manufacturing business that is running in the US, it's completely different than running in the Europe or running in APAC. So user persona is also completely different. That's a pro tip that I'll give you from the experience or the losses that we had or lessons we learned, right? So businesses are also different, ICPs are also different, even though it's the same product manager, same manufacturer, same laborer, the way they operate is going to be different based on the region. So don't assume that when you're launching an app, you can launch for all regions. Launch local, build local, scale locally, then you can go global. Yep. So that's it, second lesson. Like I said, the second lesson to repeat, so don't neglect the fundamentals for hyper growth. Just stay local, try to build the foundation before you grow high. Over-engineered. How many of us here over-engineered, right? Yeah. So we want to make sure every UI, UX is perfect before we launch. That's not the case. You know about vibe coding. Everyone now vibe codes. So there's a balance between that, right? I cannot launch a prototype as an app and ask someone to pay for it, right? So don't over-engineer before you launch. There's a flip to it as well. This is a mistake we did. So we took a use case where we were saying, hey, we are going to replace WhatsApp. Don't use WhatsApp. We are going to build WhatsApp. So for building WhatsApp, we have to do Android, we have to use native coding, we have to build an iOS platform, we have to use React, we have to use AWS. Even in AWS, we have to make sure that our chat is scaled for millions of users. That's what I was telling. There was another developer who I worked with in the initial stages. He was starting to test the app such that it works for millions of users from day one. No one is going to use your app on day one for millions of users because we assumed like we will be replacing WhatsApp on day one. No one knows there is an app called Juggle unless you market it, right? So two lessons from here. One is pick a problem that is easy to solve or that doesn't involve many technical or technologies there, right? So here we picked a problem chat. So for chat, you cannot go for a React application because it will be slow and we are competing against WhatsApp. It has to be very fast. So we have to build code in Android, iOS, and React. Otherwise, we would have gone for a hybrid application just using React framework. The second problem is we thought that on day one, millions of users will start using our application. So that way, we were doing load testing and we were spending server cost for load testing, which was not really needed at all, right? So why millions of users will be there? We no need to test for scaling. Might be we got like 100 users on the day of launch, but one thing we got on the day of launch is someone attacked our server using brute force. They know that we are launching on day one, so they made sure they know that our WAF was not that real strong, so they did a brute force OTP attack. But other than that, we got like 100 users on day one. Yeah. So don't over-engineer. Just keep it simple, try to get as much feedback as possible, and make your foundation very, very strong before you go global or scale it. Okay, so to conclude it, you can see in the screen, these are the top 50 apps, AI-based apps in the last 2 months. Like this is a report generated from Anderson Hodes. They are a big investment firm, A16Z. So these are the top 15 apps in the Play Store or web or wherever, right? The top 15 apps, most active AI apps used. So if you see, AI is everywhere, right? Most majority of the people who build these apps in this screen are not like big players like Meta or Facebook or Microsoft. They are all players like people like us who are in this room, who are might be a little bit luckier, who took the first action, right? So for example, if you take the app number 50, which is on PlantNet, that's a very simple idea. So what that app does is you have to go use your app, scan a plant, and it tells you what is the heredity of the plant, or what is the hierarchy of the plant, and what you need to do for the plant, like whether you need to water the plant, is it overwatered or less watered, what care do you need to take for the plant. So it is number 50, it's a simple idea. They use AI model behind the scenes. They have fine-tuned the AI model to work for a plant, like a set of plants. They have fed all the AI plant data into the AI model. So it gives you a suggestion of what you need to do for that particular plant, what care do you need to do for the plant. So the idea is very simple. All I'm trying to say here is the technology or the development doesn't need to be complex. All you need to do is just solve a simple problem, and AI is here, and this is the right time for us, all of us, to solve problem using AI. Again, this is the top 10 AI agentic app applications which are generating revenue. In this, if you see Replit and Lovable, they are the number one, the first companies, 2 companies to reach 1 billion ARR in 6 months. Lovable and Replit. I think they are the fastest to reach 1 billion ARR. I don't know if it is 6 months, but they are the fastest to reach 1 billion ARR in any SaaS product. So these are top 10 agentic apps. You can see the revenue that they are generating. So AI is here. So we are also building on agents. So we have built like around 9 agents, and we are releasing few more agents in the coming weeks. So AI is here to stay. AI has changed how we develop, how products are being built, right? So AI has changed how products are being built. AI is there from development to testing to marketing to sales. There's no SEO anymore. It's AEO or GEO, right? So all I'm requesting everyone of here is, let's not just watch from the sidelines of all the AI startups, right? Let's start building AI startups, right? So it could be like so one of us from this room, right? Could be one of the in this top 50 list. So AI is here for us. Let's start building startups. Let's use on some of these lessons. Might be this help you all. So this AI boom is here for us to stay, and for any product development or speed of development, so AI is here too. AI is going to help us, and any lessons that you have learned from here is going to help you on that. Thank you. So yeah, I'll just go to my. So this is my LinkedIn, so feel free to connect. So if you have any product ideas or anything that you want to ping me or DM me, in case you have been working on something on the sidelines and you want to establish or you are planning to release, you can feel free to ask me for any questions. Yep. And I also have some small giveaways for you all. Like like for the first 3 people who can ask me a question, I want to give you a giveaway. Yeah, good. That's a secret. Yeah, good.
What would you recommend if the product if there's a product that's already established in the market? Would you recommend switching to a different idea, or maybe if you're able to find something that product can offer, do you think it's worth pursuing?
Yeah. So if the product is already there, it's about checking their TAM or SAM. So what is the total addressable market and a serviceable market? But those are all just metrics also, right? So what happens is, certain times what we feel, the product is already there, but there are some gaps in the product. Like for example, let's say there's WhatsApp, but WhatsApp didn't have, I know most of you are using WhatsApp or Telegram or Discord, right? They didn't have communities feature. A lot of people built applications just for communities because WhatsApp didn't have communities feature. But soon in 2-3 years, WhatsApp released communities feature. So it's all about how are you trying to create and carve out and separate niche in the same industry or same place, which that player is not there, so you can attract new users, or are you trying to move the users from that application to your application? So it's about the habit, right? If they're already using, like you say, the competitor is already there in this space and there are already a lot of users using the app, and you're going to build a new app to attract them to your application, that's going to be a tough sell. But if there is a small carved out space where there's no one in that region and you can build a solution for that, that could be good. Yeah. So it again depends on how big that player is. A lot of applications they build on top of Salesforce, like they just fill the gap that Salesforce doesn't have, and it get acquired by Salesforce or it get acquired by SAP, because they're just filling the small gap. Like let's say there's not efficient dashboard option, or there is no option to generate leads or incentives for leads through Salesforce. They build that application and it gets acquired by Salesforce. Yeah, it depends on the type of problem or the type of the addressable market. Yeah. Go.
How do you determine if the problem is the problem worth solving so that people actually will pay money for it?
That's a really good question. So that's something that we initially missed. The problem worth solving is how much pain you have. Let's say you have a stomach pain or a tooth pain or the throat pain or leg pain, right? So when you have something on your tooth, it's unbearable, right? But stomach pain, yes, you can manage. So how hard or how powerful is that pain is? That's the problem worth solving. Let's say it's a nice to have tool, they never pay for it. We initially started like that. When you go demo it, yes, they like it, they want to use it, but they never use it because it will not go through the implementation phase, because they'll keep it as a low priority of their business. They don't have immediate need to use it. Anything related to CRM, anything that is related to revenue generation, they immediately want to do it. So because it's a pain for the business, like in my sector, because I am selling to business, B2B, anything that is related to revenue for that business, they're going to buy it because it's going to impact their revenue. They want revenue to run their business. So that's why you see a lot of CRM tools coming in the market, because any CRM tool, they want to buy it because they want leads. Like Clay has reached like 3 billion valuation into 1 year. They just give you leads, Apollo.io. So there are a lot of CRM tools coming in the market because I need to get the leads, customers to get my revenue. Yeah. So how big is the pain is, that's a problem we have to pick. Yeah.
You talk about how you have to have strong product fundamentals, but you don't want to over-engineer. And you have to, obviously you have to market your product, but you don't want to over-market before you have. So how do you make sure that you're keeping that balance as time goes on?
So it's about the progress that you're making. So sometimes like you have built many things, but you're not asking proper feedback from the customer, right? So I would say it's more of intuition and how much budget you have in your bank to do it. So I am mostly taking care of product and engineering, and I am my co-founder who takes care of marketing and sales. It's always a struggle between both of us. I say, I already built so many applications, why are you not marketing? And his side is, hey, we have less funding. If I spend for marketing, and if the user don't like the app, he doesn't use the app, the money I spend for marketing is gone waste. But if I spend the same money for building a product, I can at least exit by selling this technology or the IP to someone else. But if you spend for marketing, and if the user comes in, he tries to use the app, and he doesn't like the app, he's not paying for it, all the money you spend for marketing is not going to come back, it's vanished. So you have to treat that way, try to do a balance between both. So when you're spending for marketing, you have to have the market fit, as well as is the app stable enough for the users who's coming in, are we going to get the revenue back from that user? Yeah.
How do you find like your first like 10 or 50 users? Like how do you do that initial market research to see if this is like a problem worth solving? And like
So
what problems those users are facing?
So first you have to narrow down your ICP. That's something that we never did. We went very generic. Whoever asks there is a need, we just gave the app to testing and we got the feedback and we keep building. So narrowing down the ICP is really, really critical. Without doing that, you should never start building or getting feedback from users, because the ICP can be different within the industry also. So might be, let's say in a business, operation manager is different from an technical manager compared to a product manager. So everyone's thought, everyone's operation, everyone's the day-to-day is completely different. Yeah. Yeah.
But like, do you have any like specific like actions that like I could start with? For example, like, I'll give you an example. Like, let's say I want to like build software for like small businesses.
what is your first step? Do you just go on like LinkedIn, DM like a bunch of people that?
Yeah, you have to. So what we did, we interviewed like 15, 20 small businesses. We asked them come to our conference room. We interviewed them. Then from there, we have to narrow. We didn't narrow down exact ICP. That's a small mistake we did. So you have to narrow down the exact small business. In that small business, who's your ICP who's going to use? Is it the marketing manager or a sales manager? Even in that small business, what industry you are going to target? So when you go on demo to the VCs, most often that's what they ask. What vertical are you targeting? If you go and pitch anyone, if you say and my app can be used for any industries, they think that you're bluffing. It's not working, your app is not working. So they ask you first, what is the vertical you're working on? What is the ICP or user persona that you're working on? Yeah, sorry, we're on time, okay. Thank you.